Hey everyone, this is Shashank Mishra, currently working as Data Engineer 3 at Expedia, and in today's video, I will be talking about basics of SQL with its practical implementation. So before starting the video, if you are new to the channel, then make sure to hit the subscribe button and press the notification icon. Also, if you want to keep learning from leading industry experts, then make sure to check out Scalar's event page, link is in the description. So now let's get started. So to start with the basics of SQL, first we will try to set up the environment in our local machine, and to our implementation part we are going to use the widely used transactional database which is MySQL. So first let me show you how you can set up environment related to MySQL in your local machine, be it Windows, MacBook or any other laptop, desktop you are having. We can simply download it from the MySQL dev, this environment, and we can set it up very easily in just few steps. So what you need to do, you can open the web browser and simply type MySQL workbench, and after that you can mention your machine name directly if you have Windows or Mac, whatever it is, and simply click here, and after that you will see this link dev.mysql.com. Simply click on this URL, and here it will redirect you on that respective machine environment you have, the operating system, and even you can select it directly from here. If you have Windows machine, you can simply toggle onto that option, and here it will provide you this option to download the respective jar files or any kind of libraries which can help you to set up this workbench. So I am using Mac OS, so I'll just click on here and then I will download this .dmg file. I can simply click on it, and here it will ask for the login or sign up. No need to do that. Simply click on this no thanks, just start my download option, and it will start downloading this package which we can see here. And once this download part is done, it's just all about the double click, and that .dmg file will directly install this MySQL workbench in your system. So here as we can see, we have downloaded this one, and since this MySQL workbench is already installed in my system, no need to do that again. So I'll directly show you how you need to proceed on the MySQL workbench, how it looks like and how we can perform different operations. So let me go there. Cool. So after installing the MySQL workbench, it will look like this. Its environment, or it completely provides you the ID sort of environment where you can write your SQL commands. Also, once you will start setting up MySQL workbench in the local, it will ask you for root user and password, which you can set up accordingly, because this MySQL workbench also provides you MySQL instance, because this is a background service which needs to keep on running in the background. So as soon as you start the MySQL workbench from your machine, right, you need to provide the password, you need to provide the username, and then it will simply start it. And after that, this is how the interface will look like. And after that, I will guide you what are the meanings of these keywords which are written here, and what all operations we will be performing and how we will be performing. So first part is the databases. So when we talk about transactional databases or database management system, so MySQL is what? MySQL is actually a database management system which provides all those kind of environments where we can manipulate the data by using some query language, and typically used like the SQL. Okay. So first let me show you how we create the databases and what is the meaning of schemas here, so that you don't get confused, because the common keywords which are used across different databases, that is database itself, and there will be different databases where this keyword might get changed, like key space schema. So I don't want you to get confused with these terms. So in the MySQL workbench, the meaning of schema is very simple. It is just like creating a different folder inside this ID itself, and inside that one we are creating different databases. So that is the simple meaning, and you don't need to do any sort of custom settings here. As soon as you start exploring it, you can definitely tune those settings, but by default whatever interface it will provide, it's good to go. You can execute your SQL commands, queries, everything. So first and very basic thing, how we create the database in SQL, what's command we will be following. So the very basic thing you can see, right, these are the databases which I have already created for testing purpose, like DemoDB. Sys is something which comes by default, because this is what? This is a software itself. This is you can say workbench, or it needs to store some metadata, right? Whatever things we are creating, whatever commands we are executing, so some default tables, right, as a root user will be set up, which different user cannot delete, which different user cannot manipulate. All right, so similar thing we can see, these are the default databases like sys, but this DemoDB, test2, testdb, testdb1, this is something which I already created, but here we will create a fresh one. So what's the command for that one? Create database, and we can give a database name here. So for that one, first demo. Okay, so you might be wondering how to open this notepad sort of file here. So we can click on this one, this left option in this menu bar, right, plus symbol. So what it will do, it will open a new SQL file, like this is a blank file which you can see. All right, and this one which I already opened, and I have placed these placeholders so that we can follow a proper sequence of SQL commands, and you will be also able to relate it how these things are executing step by step. So create database, first demo, and now how to actually execute it. Okay, so just select this portion from here and click on this thunder kind of symbol. Okay, so if I click on it, then here in the logs you can see this log has been printed, how much time it has taken, or if it's a green check symbol, that means this command has been executed successfully. By chance, let's say this command was supposed to be failed, then we will also get a proper error message so that we can debug it and we can fix it. So here, since it's successful, right, now at this moment we are not able to see this database in this left panel. Okay, so what's the reason? Sometimes it needs to keep on refreshing itself. So what you can see this refresh symbol in front of this schemas keyword. So just click on it, and after that it is easily visible to you. This database has been created, first underscore demo. And if I expand it, then you can see multiple options are there: tables, views, stored procedures, functions. So this category is basically to provide a hierarchy in this ID itself, so that let's say we are creating few tables inside a database. As soon as we will create it, those will be visible here with the column names and its data type. All these kind of metadata information will be mentioned here. So after creating a database, we need to look at the command that how to use it, because different tables will be created inside different databases. So what's the command to go inside a database? For that one, we can write use database, and here we need to mention our database name itself. No need to use any database keyword, simply use and mention the database name. And if I execute it, right, this command is also successful. Now we are inside the first demo database, and if you have observed, there are multiple databases, but when I clicked on it, when I executed it, this is something which is now focus area, right, the bold section on the ID itself. So this is the cool part, I would definitely say. Now we have created a database, we have seen the command how to use it. Let's look at how to drop a database as well. Dropping a database, let's say earlier we were doing some stuff for our testing or development. Now that database is not in use, how to actually delete it completely. Okay, so for that one we can use the command drop database and database name. Okay, if I execute this one, so since I have created this fresh database, I don't want to delete it. What I can do for my testing purpose, I can delete any existing database. Let's say I am trying to delete test_2, which I created previously. So test_2, let's execute it. Okay, now you can see this is also successful, and as soon as I execute it, it is removed from this left panel as well. All right, so the database creation part is done. Now we will move that how to create the tables inside a database. Okay, we created it, we used, now we are actually inside our first demo database. So this is the command to create a table in the database. These are the keywords which we actually need to follow, like create table. Okay, and after that we need to mention our table name. So each table in these kind of transactional databases is like a row columnar sort of data. Okay, so column name just like a variable which will have its own specific data type. So when we create the tables in MySQL databases, we need to provide few informations. So if you look at this entire command, this is a command we will be using to create a table. So after providing the table name, inside the parentheses, these parentheses, we are mentioning different column names, right? And after that we are mentioning the data type. Then we are mentioning few keywords which you might be wondering what is that and what is the reason to use these things. For example, not null, right? Then this is the keyword default. Okay, and this is another keyword, primary key. So let's try to understand one by one what kind of sequence we need to follow. So first we need to mention the column name, and after that we need to mention the data type. So different type of data types available in MySQL database. If some column which is supposed to hold the string type of value, it should be named like this, varchar. So when we define the data type as varchar, so by default it will pick some length, but if we want to customize this length, for example this particular column will hardly take 10 characters, so we can simply mention this thing, right? And let's suppose we have different data types, for example integer values, float values, double values, the date type of columns. So those type of data types are also available. Next thing, these are the keywords actually used to define the integrity constraints. So when we talk about the transactional databases, one of the important property is the consistency part, and we can keep the things consistent when we apply some rules, and that is something which is known as the integrity constraints in the transactional databases. And I have created a similar video on Scalar's YouTube channel related to this topic, and it's a long video where I have covered all the database management related fundamentals, so you can check that video here. So talking about the integrity constraint, not null and default is another type of integrity constraint. Let's say you have defined a column, and while inserting the values, let's say somebody is inserting null value, okay, and value is actually missing from that insert command. So by default we don't want to keep this column empty. So what we will try to mention some default values, so that if somebody is providing null sort of values, this value will be populated with that particular default value. That is the reason of this integrity constraint. And similarly you can see not null is something which has been used multiple times. So this constraint will prevent any kind of insert command which is trying to insert the null values, and that is the reason these rules keeps our database tables properly consistent. This keyword is something which is very much important. when we talk about the transactional databases, the concept of keys is super duper important, and one of the, you can say, most asked interview questions as well, like what are the fundamental of keys and why it is very much important. So the fundamental of keys plays a vital role in the data analytics databases, because when we try to keep our databases normalized, different tables will be created, right? And if there is no way to connect those two tables together, then it would be hard to do the data analytics or to perform any kind of database related operations. And that is the reason there are two main things with respect to the keys. First is primary key and second is the foreign key. So let's understand what is primary key. It is like a key element which we generate in front of each row, or you can say a combination of columns we can use from the table which we have created, and it is uniquely providing the identification to that particular record. Overall, what we can say, this is the mechanism or this is the keyword. Let's say we have a specific column in our table, for example employee ID. For each employee in an organization, they will be having a different unique identification numbers, right? Even two person having the same name, they might not be having the similar employee ID, right? So that is the same thing. It will help us to uniquely identify a record from a table. Second, you can see this is another table we have defined, and it is like employees. This table we defined for the offices, right? Here we are following same kind of integrity constraint, but another thing which I was talking about, the foreign key concept. So concept of foreign key is like, we can understand with a practical example, right? If somebody is visiting our country from different country, we call them foreigners, right? Because they are the primary citizens of their own country, but they are traveling in our country and just sort of reference. So same kind of concept. If we have more than one table and there is a key attribute which is a primary key of another table, and we are referring it into our table to establish that kind of connectivity which I was talking about. So in that case, we will be using this foreign key integrity constraint. So how to declare it? This is the syntax we can follow, like constraint name. So this is the integrity constraint. For each integrity constraint, we can provide a unique name, so that moving forward, if we want to add more integrity constraints, we want to alter it or we want to drop it, we can easily do that. So first we declare the name for this integrity constraint, then foreign key keyword. This column office code is something which we are referring in this employee table, and you can see in offices table, office code is a primary key, right? And that is what we are trying to establish. This kind of connectivity means references. So in employees table, office code is present here, and to establish that connectivity, we need to tell in this create table command that this column is present in which particular table as a primary key. That's what we have done here. So let's execute these commands one by one, and we will be able to see these two tables inside our database. So I have selected it, and as soon as I execute it, you can see this is successful. And if I just refresh it, then you can see one arrow sort of symbol has been created. And if I expand it, you can see offices table has been created. Now if I expand it further, right, you will see this thing, this option for the column. So here office code is there, city, phone, address line 1, address line 2, state, country, postal code, territory, everything has been created. All right, this is done. Now let's create this part as well. So I have executed this command. This table has also created, and if I refresh it, we can see employees, right? So if I expand it, all these columns have been created, and you can also see there is an option of foreign keys. So if I expand it, right, you can see this constraint which we created, right, employee IBFK underscore 2. That means this is something which is referring to the foreign key part. Cool. So we have created our tables. Now let's say we are inside particular database and we want to check how many tables are already there, and we just want to have a quick look at it whether table has been already created or not, then what command we can use? So command is very simple, show tables. Okay, if I write it in this way and if I execute it, right, you can see this is how we are getting our result. So employees and offices, if you have let's say 50, 100 tables, all will be listed down here in the form of output. Alright, so now moving to the next one. So after creating the tables, we saw that how to get the list of these tables. Now let's say we have created a table and we want to delete it, right? So there are three things to understand with respect to deleting a table or deleting a data. So there is a main difference. When we talk about the deletion, either we can delete the data only or we can delete the entire table structure. So there are three commands, right, which are typically related to deleting the data or the table structure. First is drop table, second is truncate command, and third is a typical delete query. So when we talk about the drop tables command, what it does, it can delete a particular table completely, including the data and structure, right? And when we talk about the truncate table command, it will simply erase the data, it will not delete the structure of the table. And same goes for the delete command. Let's say we have some specific requirement to delete specific records from the table. So for example, let's say you have an employee data and now you want to remove all those employees from some specific location. You can put some filter condition and easily those records will be deleted from the table. So first let's try to run this one. Let's say we have created these two tables, right, which we can see. I will just quickly drop it. I will write a command to drop this table first, let's say the employees, right? So if I write the command, this is how it will look like, drop table and table name, right? And if I execute it, right, this is successful. Now in this left pan, right, you can see inside this tables now employees table is not present. All right, now if I do this thing, I apply the truncate command for the offices table. So this is how it will look like, truncate table and our table name is offices. So if I use it and if I run it, let's check whether the table structure will be deleted or not. And at this moment, since we haven't inserted any data as of now, so if I simply run this command, ideally nothing will happen because our table is still empty, but we will verify whether table structure is gonna be deleted or not. So if I execute it and run it, this command is successful, but you can see the office table is still there. That's the difference, and this is also one of the most important interview question, the difference between drop command and the truncate command. All right, so first let me bring back the employee table again. So if I select it and execute it and refresh it, my table is back. Cool. So far we have seen the basic steps. Now let's understand how to put some data inside a table. Okay, so you can see I have already created a template to insert some bulk data inside the employee table and similarly in the offices table. So nothing to worry about. If you want to follow all these steps, this whole execution step will be provided to you. You can find this piece of code which I am writing here or the SQL commands, the GitHub repository link will be provided in the description, and you can use all these commands as it is, whatever I have been writing here. So insert into then table name, and inside the parenthesis what we need to do, we need to provide the column sequence. So this is a typical syntax of inserting multiple records. So for an example, at this moment what I want to do, I just want to insert one single record. So how we can do it? So let me copy it from here and I will just paste it and will show you how we can simply insert one record and what is the actual meaning of this sort of bulk record. So this is the command we need to follow: insert into table name, and let's say you are pretty much clear about you need to insert data in all the columns. So in that case you can skip this part, that means defining the column names. You can completely skip this part, because if we don't put this column sequence, this insert statement will understand it like you want to insert data for all the columns. And after that we need to use this keyword named as values, and this is important. So see, when we talk about the table, and here you can see, right, this office table has also a proper structure, right? These column names are not randomly located anywhere. So while even inserting a particular record, we need to follow this sequence, okay? And that is the reason sometimes, let's say there are 50 columns in my table and I am supposed to insert the values for hardly 5 to 10 columns, right? So how to do it? Obviously we need to selectively provide the column names, and the column sequence which we are providing here, in the same sequence we need to insert the data as well. Else what will happen? We will get the exceptions of mismatch data type. Alright, so if I execute this command, and ideally it will insert this one record and we will evaluate it whether this is inserted or not. So let me select it, and if I run it, we can see. So as you see, when I executed this insert command, it is throwing an exception that cannot add or update a child row. And why is it happening? Because this is the first time we are trying to insert the data, and as we can see from the definition, this table, employee table, is actually referencing a column from this office table, right? So since this kind of constraint has been maintained, obviously the level of data insertion should be from parent toward the child. So in this case, what would be the parent table if we just consider this foreign key kind of relationship? Obviously the offices table. That means whatever values we are trying to refer in this employee table, first they should be available in the offices table. So instead of executing this command alone, first let me insert something related to this data, right? So first, I think I have clearly explained how we can insert one single record. You can just simply execute this command, and this is a variation of same insert command when we want to insert multiple records in one single insert statement. So in that case, what you need to do, only values keyword will be used once, and after that in the parenthesis what we need to do, we need to simply mention our column values, comma separated. No need to use this values keyword multiple times, just the records enclosed in the parenthesis. So first what I will do, I will quickly insert this entire data, and I selected it. As soon as I execute it, now we can see this insert is completely successful in the offices table. Now if I come back here and if I ignore this one single liner insert command and I directly try to execute this one, so we shouldn't be getting any kind of error now of inserting data in this table. So I have selected it, and as soon as I execute it, you can see this one is also successful. All right. So if I just refresh it one more time, and how to just get the preview of the data, let's say this is the amount of records we have inserted, how we can get the preview. Okay. So for this one, if I click on this thing, right, let's say employee table and the third option. So if I click on it, ideally we can see this is the preview of our data which we are getting. Ultimately it is running a select command, and I will specifically talk about this one as well. So don't worry about it at this moment. So this was about the preview. Now insert part is also done. We have inserted data in both of the tables. We will look other important commands in the SQL which is, let's say, alteration of the table, because there could be multiple scenarios where we want to change the data type of any particular existing column, or let's say we want to insert a new column, right? If we want to perform these kind of operation, in that case we need to follow this syntax, right? The alter keyword. Okay, so here let's say if we come back to our table structure, there is a column, let's say address line in the offices table, address line, and its length is 50, right? Its length is 50 at this moment. So what we can say, we want to run an alter command which will simply modify the data type or simply increase the length of existing address line 1 column from 50 to 100. So this is a modification in the table structure itself. So for that one we can use this alter command. So alter, and after that we need to mention the table name, which is the offices, and then our column name. So alter this one, and here what we are going to do, we are going to modify it, right? So modify keyword, alter offices, modify, and the column name is address line 1, and after that we simply need to mention the new data type. So this sort of thing can be implemented for other type of conversions as well. Let's say you have one column which is of integer type at this moment and you want to change it to the float or double, that kind of data type change we can also do it from here. So alter offices, modify address line 1, and the new data type will be varchar 100, right? And one keyword is missing, which is alter table, right? So the complete command is alter table offices, modify address line 1 varchar 100. So if I select it and if I execute it, we can see this is successful now. And if I click on it, if we come here and if I click on this column as well, okay, so how we can now identify it, that whether the data type has been changed or not. So for that one, so in order to see the complete structure of the table, what we can do, we can simply run this command, show create table and our table name. After that, what will happen, we will get the entire table structure, and if I execute it, right, we can see, let me just expand it so we can see the complete value. Now just focus on this part, you can see address line 1 has been changed to varchar 100. That is the thing which I wanted to showcase earlier. When we created this table, its type was varchar 50, now it has been changed to varchar 100. So similarly, if we want to add a new column, for an example, so command is very simple, alter table offices, now add, and here we can mention a column name, right, anything, let's say ABC or column 1, and just mention the data type, and after that simply selecting it, you can execute it and the new column will be added. So this is the syntax for that one. Now show create table we have seen the alteration of the tables as well. Now coming to the important part, which is to query the data which we have in our table. So in the beginning, when we started with the basics of SQL, right, we followed few sequence of the columns, right? So there are 3 categories of SQL commands as well, right? First is the data definition language, which is DDL. So data definition means any kind of SQL command which we are using and it is trying to directly, indirectly impacting the you can say structure of the table, right? Let's say we are creating it or dropping it. These are the things, these are the commands which are eventually affecting the structure of the table, and even including the alter command. So that is related to data definition language. Coming to the data manipulation, so insert command, update command, delete commands, these are the commands which are actually manipulating the data which is residing in the table. Third is the data query language, DQL, and DQL means where we are trying to select the data which is inside the table. So this is important because most of the things will be done with this one, like how we can get the few selected columns from our SQL table and how we can rename it, how we can perform different operations, right? So quickly look at the examples of it. So here, let's say from a given table, if I want to select all the columns, so the command is select star from table. So here, if I mention offices and quickly I execute it, we can see we are getting all the records from our offices table, right? So in total we inserted 7, we have in total 7. Now let's say what we want to do, we want to simply get starting 2 records or 5 records. For that one, what we can do, we can use the limit keyword in our select operation, and after that we can put some numbers and only those number of records will be displayed in the output. If I select it and I execute it, you can see now only 1, 2, 3 records we can see in our output. Now let's say we only want to select few specific columns. So how we can do that? That is also pretty much simple. Just write those specific column names and that will become the part of our final output. So here let's say we want to display office code and city only. So office code comma separated second column city, right? And now if I execute this command, we can see only office code and city has been displayed in the output. Looking at the third aspect of it, which is important, so this thing, how to rename a particular column in the output. Okay, so if let me just run this one again so that I can see all the columns. So here let's say this is the postal code column, right? Normally we call it like a zip code or something. How to rename our columns in such a way? So for that one, the command is also very simple. So if I put it in this way, the second column is city and after that the third column is the postal code. So I will make it postal code as. So this as is the keyword which we need to use in order to give some specific name to any of the column or any derived column in the final output. So I will name it like a zip code, okay? And if I execute it, we can see this output where that postal code column has been changed to the zip code. Now another operation we will look at. So if I query this entire data of the offices table, right, we can see state, country, postal code, territory, all these things. So one of the common things, right, mostly when we talk about the data analytics, so let's say there are duplicate entries for any particular column in our table, then how we can get the distinct values out of it, right? So we have one important operation which we can use here, that is the distinct keyword on any specific column. So here in our data we can see country is something which has been repeated multiple times for different rows, USA, France, Japan, Australia, UK, right? So let's try to figure out if we have, let's say, lakhs of records, millions of records in our table and we want to just identify what are the distinct values in particular column, how to do that. So for that one we will use distinct keyword and after that just mention the column name. So select distinct country from offices and just execute it, and we can also rename it. As I mentioned about rename, I can name it like distinct countries. All right, so let me execute it. We selected it and execution done. We can see now this one, USA, France, Japan, Australia and UK. Earlier there were 3 entries for USA in the input table. Cool. So we have seen this thing. Now another cool aspect of this select command, which is the data analytics related, means how we can apply the inbuilt functions. Let's say we have our data, we have the table, how to apply inbuilt functions like count, min, max, sum, average, standard deviation. So all these things are already provided in the SQL library. We simply need to use it on the respective columns. So I am going to write a select command which will calculate something, right, on the specific columns. Let's say finding the maximum, finding the minimum, and for that one what I am going to do, I am going to use the employee table. So select star from, you can say, the employees table, and let's look at what data we have. So after selecting it, we can see this is the data, and this employee number is something which is of integer type. So definitely if there are numerical data types, we can apply count function on that one. Not just count function on numerical data types. Count is something which will help to count different type of things. Let's say how many rows are there, distinct count for the column values. But other operations like sum, min, max, average, standard deviation, this is something which can be only applied on numerical data types, not string sort of things or the date type kind of things, correct? So select star from employees. Here I am going to use employee number to write a select statement where I am going to do different operation. First, let's say I want to count the total number of rows which are present in our table. How we can do that? We can use this thing count star, and I can give a name to it, total rows. This one will calculate the total number of rows available in my table. Second one, let's say I want to find, because here you can see, right, these are the integer values, 1002 numerical values. So if I randomly try to identify what is the minimum value, maximum value, I can definitely do that. So for that one I am going to use, let's say, this min function, and I will pass the respective column name, which is employee number, and similarly I will name it like min emp num. And if I want to identify the maximum employee number we have assigned so far, I can change it to max, and it will be also renamed to max. Similarly, if you have another column, right, the example you can take here, the salary column in the employee table. Somebody asks you to identify total salary a company is paying to their employees, right? You need to apply the sum function, and similarly you need to identify the average salary of the employees within the organization. You can simply apply the average function, right? All those kind of calculations will be done very easily. So this one we have already did from employees, and if I execute it simply, right, we can see total number of rows, total number of records we inserted 23, minimum employee ID number was 1002, maximum 1702. So this is how inbuilt functions we can apply on different columns in the SQL table. Cool. So when we talk about the final output or performing the select queries, sometimes what we want as an end user, we want our data to be organized in some specific column names, maybe ascending, descending. So how to do that in the SQL? For that one we will be using the order by clause. Order by clause, we can provide multiple comma separated values and their respective arrangement, let's say ascending, let's say descending, all those things can be done. So if I display our employee data one more time, we can see this is the data and how we can arrange it. So here if you look at the office code, right, so office code is something which is randomly, right, let's say 1, 2, in between 4, then 7, then 6, then 5, then 4, okay. So one arrangement can be done on this one office code in the ascending order. This is number one. And another one can be done, for an example, the reports to, right? Reports to is basically the manager ID here, and manager is an employee itself, so this ID is eventually belonging to these number here. So this is how we can arrange our data. So let's see how to do that. First I will only apply this output on the reports to, not only reports to basically the office code column. So select star from employees, order by keyword, office code, right? So if we execute it, then let's see what happens, what output we'll get. So here now you can see it is properly arranged for us. 1 1 1 1, these kind of values are together, 2, then 3, then 4, then 5, then 6, then 7. So by default, when we apply the order by clause, it arranges our data in the ascending manner. So if we want to arrange this data in the descending order, what we can do, we can explicitly mention this DESC keyword, and now if I execute it, this whole arrangement will be done in the descending order of the office code, which we can see here. Now if we want to apply multiple level of ordering as well, so I'll give you an example how it can happen. Let's say you have employees from different companies, and you want to arrange first your data in the form of the ascending order of country codes, okay, or you can say simply countries. So any country which is starting from, let's say, letter A, if you talk about the lexicographical order, those will be on the top, then starting from B, C, and so on. And there will be records which will be duplicated, and multiple duplicacy there will be, like the USA related records multiple time. And within that particular section, right, the chunk which has been created for USA employees, you want to arrange the data in the descending order of salary. So what kind of command you can follow here? I can show you the placeholder for that one. So select star employees, order by, let's say, country, and comma, second is the salary, which is in the descending. So first what it will do, it will try to arrange the records in the ascending order of country, and if our SQL engine sees that there are duplicated records for the country, within that it will just arrange the data in the descending order of salary. So that is how it is going to work here. Okay, so now we will see how to filter the data set. If we have created our tables, how we can write that particular syntax which will give us some specific result in our output, and that is being called as our data filtration, or the filter logic, or filter clause you can say, but its technical word is where clause. And I will show you how we can apply selective operations like and or operation, like, in, is null, is not null, and there can be multiple ways we want to query our data with some specific conditions, right? So if we look at our employee data here, you can see multiple ways we can select the specific chunk of data, and that is the condition we need to mention. So for an example, here we can see office codes, right, and in each office, right, different folks from different designations are also working, right? So if we want to do some kind of selective search, it is easily doable. So let me write it in the way we can query the data. If we want to relate here, we can see reports to is something which is sort of a manager ID. So here we can see this employee whose employee number is 1501. He is actually reporting to 1102. So let's look at who is 1102 here. You can see Bonder Gerard is the employee who is the manager of this employee 1501, and its name is Larry Bot. Okay. So in the same way, right, a manager can manage multiple employees, right? So we want to query all those employees who are reporting to employee code 1102, or we can say Gerard. Okay. So select star from employees where, this is the keyword we need to use, where reports to, and we need to check what was the data type of this column as well. So here if we come back and we check, the data type of reports to is actually of integer type, right? So we can simply mention it as it is, because if it was, let's say, of a string type, we need to mention it in a different way. So reports to equals to, this is basically a equality comparison, 1 1 0 2. Okay, so this is the filter condition we have applied. We are trying to identify all those reports, we are trying to identify all those employees who are reporting to 1102. Now if I select it and if I execute it, we can see, right, this is the list of all such employees who are directly reporting to 1102. So this is the one simple where clause implementation we have seen here. Now let's discuss what could be the syntax where we want to concatenate multiple conditions together, and that can be any logical condition, and kind of condition, or kind of condition. So let's try to do that, and for that one we will again look at our employee data, and we can see, right, these are the things which we can use for our practice multiple conditions. So here I'm going to apply this condition. First let me display the entire data set here. So if I execute it, this is the entire data set. Now let's try to check what we can use for our AND part. So we can see multiple designations like president, VP of sales, VP of marketing, right, sales representative. So here specifically if we look at this thing, the sales manager and sales representative, and these two people who are having these respective designations are working in office code 1. Office code 1 eventually having multiple designation folks, correct? So let's say if we want to filter out these records, so select star from employees where office code and the office code data type is varchar, right? So what we need to do, we need to put it in this way, enclosed in the double quotes or single quotes, so that it will act like a string. So office code 1, and another condition, let's say from office code 1 we want to identify the employee number, name, etc, who is having a designation of VP sales, right? So second will be on job title equals to VP sales. Okay, here we can see VP sales. Now if I want to execute it, this is how it will look like. Okay, we can see this record only which we wanted to bring in our output, 1056 Mary Patterson actually working as a VP of sales in office code 1. So this is a AND condition. Okay, now if we want to apply the OR condition, okay, so how we can do that? Let's say if I display the entire data, there are two things. Here what we can do, either print the data of office code 1 or print the data of all such employees who are working as a sales representative. Let's say if we want to apply this kind of condition, how we can do that? We can use this similar thing here and we can just apply the OR condition. So OR job title as sales REP means representative, and now if I execute it, so easily we will get the records for the office code 1, or if any sales representative, right, who is having this job title will be in our final output. So if we have executed it, right, we can see the records from the office code 1 are definitely included, and from other office codes we are only getting the data of job title sales representative. And why it happened? Because of this or kind of condition. Okay, so this is the another version, or now we will look at the how we can apply these kind of operations as well, right? Like this is another way of filtering the records based on some string pattern searching, right? Like, in, is null, is not null. Okay, so one by one we will also check it. So this like operation can be done only on the string based or string type of data types. So select star from employees, where what we want to do, where we want to filter out all those kind of employees who are having a job title starting with sales. It can be sales manager, sales VP, sales representative. But what we want, we simply want all those job title employees whose designation is starting with sales, right? So how we can use this operation? Select star from employee, where job title equals to, where job title like. So this is the keyword we can use, and in the single parenthesis we need to apply that pattern matching. So that pattern matching is eventually related to this thing. Means ideally it should start from the sales, after that it can be anything. So there are two wildcard characters which we can use. One is the underscore sign, another is the percentage sign. So when we apply this thing, percentage sign, after any of the string which we have written inside this parenthesis, so this percentage actually means 0 or more characters. So doesn't matter whatever is written after the sales, right? Let's say we can see sales manager NA representative, right? It will just look at in this way, that this designation is starting from sales, and after that whatever is written, I will simply pick this one. So that is how SQL engine will decide it. And now if I run it and if I execute it, right? So in our output we can easily see the data which is just related to the job titles which are starting from sales, nothing apart from that one. So this is also one of the important keyword we can say, or important operation in the where clauses. So this is the sales related, and now try to imagine multiple scenarios where you just want to pick the record. For an example, you have a data for different states and there is one column named as feedback or comments, and you want to search only those records where in the feedback some specific keyword is mentioned. So when there is a long text and you are not even sure whether that particular keyword might lie, so what we can do, we can put percentage before as well, and whatever text we want to identify, that should be in the middle, and after that we can also put the percentage. So how it will look like? Sales anywhere in the particular string column value, and before that whatever words are there doesn't matter. After the sales keyword, whatever words and characters are there doesn't matter. So for the example of that wildcard character which is underscore, let's try to implement a condition where all those employee names, or you can say employee records, we want to fetch whose first name is having only 4 characters. If this kind of condition we want to apply, so we are trying to strict something, we are trying to apply some strict condition on the characters present inside the first name. So here we will replace it as first name, and it will be like underscore 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 4 times. So one underscore represents one character here. So in this case, this filter condition will try to check that what are the employee records where this pattern is exactly matching with first name. So if we give a quick view here, we can see name starting with Mary, Jeff, right, and Louis, after that Mami, right, Andy. These are the names which are having only 4 characters. So ideally these kind of records we should get in our output. So if I just select it and execute it, you can see these were the records which I was talking about we are getting in our output. So next one is related to the in operator. So in operator is just like a lookup kind of thing. So when we try to write those kind of queries where in the filter, or you can say where clause, we want to verify that something is specific to these particular values, we are getting the output in our final result or not. So in this case we want to apply lookup related query, and for that one we can use this in operation. So select star from this table, and here what I am trying to do, I want to just bring the data for the 2 office codes, let's say 1 and 6. So how we can write this query, where office code in 1 comma, I have also mentioned 6. So now you can see this will be acting like a lookup query. In this parenthesis I have mentioned only those values which will be used to evaluate the lookup part, because in our office codes we have seen different office codes are there, let's say 1, 4, 6, 7, and in this way when we will write this query, all the records will be scanned, and wherever the office code value is matching either with this one, either with this one, that record will be captured for the final result. So now if I just execute this one, and in our output we can see we are getting the data only for office code 1 and 6. After that, if I again present this data in front of this screen, and here you will see there are few records, right, or let's say this record itself which is having the null value. Okay, and I think for this example we should use the office data because there are multiple null values present. So if I write this query and we look at the office data again, so offices, and here is the query, and we can see multiple null values here. So that is something, if we want to fetch all those kind of records, and this is also a very important step in the data analytics, data cleaning and cleansing part, where we try to identify all such records who are having garbage, null type of values, we want to discard those things. So how to actually identify it? For that one we can use is null, is not null. Is null will be based on the filter condition, where we want to check if this particular column is holding null value or not, and is not null is just a negation of that previous condition. So select, here we can see, let's say we want to identify all those records where the value of state is null. So how we can apply this condition? Select star from offices where state is null. Simple, this keyword we can apply here, and now if I execute it, in our output we can see these are the records or office codes where state value is not populated. And if we do just the reverse of it, that is also doable, and if I apply is not null, so we should be getting all those records where value of state is populated. So this is a very helpful thing when it comes to deal with the null related values in the table. So far we have covered most of the important steps, but still few things which are left, and that is the important part of the SQL commands. Like we have the data in the table, how we can update particular column values based on specific conditions. So let's try to have a look at it, how to apply the update command in SQL. And for that one I will query the full data of employee and will figure out the specific conditions for it. So if I select it and if I execute it, so here we can see this thing. So let's say what we want to do, we want to change the job title of this sales rep to proper name, right? Sales representative. We want to change this entire thing. So what we can do, we can write a simple update command and it will be done in just one single step. So what's the syntax for it? Update which table we want to update, right? Update employees table, and what we want to do, we want to set some value to this particular column. So update employees, set job title equals to this new title, which is just a complete abbreviation for the sales rep representative. And how this update command will identify how many records I need to update, right? Let's say there is a need of updating the entire value. For an example, you want to just give the same designation to all the employees. You can even do it without any where clause, because at this moment if I execute this command, it will simply update or it will replace the designation or the job title with this value, but we need to do it selectively. So how we can do it? We can mention the where condition, that is specific condition where the update will be applied. So update employees, set job titles equals to this, where job title equals to sales rep. So how this command is actually working? First, it will apply the where clause. It will identify all those employees where job title is sales space rep, and after that it will simply reset that value to sales representative. Now if I just execute this thing, so here we can see that it is throwing an exception that you are using safe update mode. So this is actually a safety feature in the SQL workbench, because these update command is something which is actually related to some changes, and easily this can violate the safety feature unnecessarily. If somebody is trying to update the values, it can create the inconsistency in the table itself, right? So by default this safe feature is set to false, means if we don't turn it off, then we won't be able to update the records. And if we want to do that, we need to mention some primary keys. So first let's try to execute a command here, how we can just turn it off. For this one, SQL safe updates, this is the command we need to use, and we need to set it 0. And now if I run it, okay, this has been executed. So ideally after this option, if we try to run this update command, we should be able to do that, and that's had exactly happened here. We can see this is successful. And now if I query the data from this table, the employee table, select star from employees, so we should get the updated data now. So here we can see this name, which was previously sales rep, has been changed to sales representative. So similarly, this is how we can keep on performing these kind of update operations. Now looking at the delete command. So if you remember in the beginning, I mentioned about the drop command, I mentioned about the truncate, and there was one other way where we can do selective delete from our table with the help of this delete command. So for that one, how we can do it? What's the keyword we should use here? So for an example, from this table, we want to delete all the records for the office code 1. This is something which we want to do, and we want to remove all the employee records which belongs to office code 1. So for that one, what kind of query we can write? So delete from employees, delete from employees where office code equals to 1. And if we execute this query, we can see this has been successfully executed. And now if I query this data again, there should not be any single record even related to Office Code 1, which we can easily see here. So that is how we can use the delete command to delete some specific rows from our input table. And same way we are using where clause, you can concatenate multiple conditions based on your need, what kind of the condition you want to use to delete any specific record. So now we will be looking at the most important operation, which is the group by, because when it comes to the data analytics, mean, median, mode, sum, average, this is fine, but we need to perform these kind of operations on some specific column values, right? And that is the very important part in the data analytics, and this group by operation is something which plays a vital role in order to perform these operations, because in this way we can granularize our data, we can granularize our output. Let's say we have our data from the e-commerce website where in a day millions of transactions are happening, and those transactions are happening from across the globe. So if you want to just identify from which country how much sale has happened for today, you just need to categorize this data. You need to create these smaller blocks, smaller chunks, so that you can apply that kind of average, sum, min, max, count related operations on that particular distinct values, and you can granularize your analytics. And for that one we can use the group by clause in the SQL. So what is the syntax here? And first let's understand what example we will be solving here. So we can see, right, different office code values in our employee table. Now let's say if your management team comes to you and they ask you to give this analytics to them for each office, or let's say within each office how many employees are actually working. All right, so how we can perform this query? We can write it in this particular form. So I actually need to tell you one very important point, and that is why I'm not putting any column in the select operation at this moment. I want to complete the group by statement first, and then I'll tell you what is the catch with the group by operation. So leave it as it is. Now select from employees table. After that we will be writing this group by operation. So select from employees, group by office code. We actually want to perform the group by operation on the office code column. That's why we have mentioned it here, and this part is done. So when we talk about the group by operation, in the final select statement we can only use those columns in the final select statement which are part of group by keyword itself. Apart from that, whatever columns will be left, they can only be used with the aggregation operations like count, min, max, average. If we simply want to, let's say, select this thing, office code, and apart from that I simply write job title, so this will definitely throw an exception. Let me execute it. Right, we can see this is failing expression here, because the reason which I explained, the columns which are present here, this is actually not the part of group by keyword itself. So let's say if I'm using job title or any other operation, I definitely need to put it in the some kind of aggregation functions like min, max, and all these kind of things. So here the main problem statement was to count the employees in each office. That's why we did a group by on office code. After that we simply want to apply this count function, right, normal count function if we are doing it, okay, and we will name it employees in each office. This is the derivation we are doing, and now if I execute it, all right, we can simply see this output. In office code 2, 2 employees are working, in office 3, 2 employees are working, in office 4, 5 employees are working, and so on. So this is the group by part, and it can be used with multiple things, and I can show you another alternative of it. If we want to group by on more than one columns, whether that is doable or not, exactly it is doable. So let's figure out what kind of columns we can actually use here for this sort of grouping. So for this example, we can see this office code and reports to. So see, manager is an employee of a company, and when you are a global company, what will happen? Different employees are working from different locations, and one manager which might be present in a different location can manage all those employees who are working from different regions. So that is the same kind of metrics we can see here. So this employee 1504, 1501, right, their office locations are different, right, 1370, but their reporting manager is same, 1102. So how we can write a query that for one specific manager, if I want to see how many employees are working from different regions, means the grouping on this level means the reports to, and this is the exercise we want to do for all of the managers, right? So if we want to do it, how we can apply this kind of multi-column grouping? So here our problem statement is we want to group it first on the manager ID basis. Within the manager ID basis, we want to group it on the office code level, and then we are counting the values. So here it is office code in the group by keyword, and after that we are mentioning, first we need to mention this reports to, and after that we need to mention this part which is office code, reports to, comma, office code. Now here what need mention here, reports to office code. Office code, and after this one the value which we have derived, that is absolutely fine, employees in each office. And now if we execute this query, right, we have got this output where we can see for, let's say, this 1102. So even the manager 1143 is also managing employees from different regions. So that is how we can see the multi grouping can be done. Now let's look at the example where, let's say, we have created a chunk, means different groups, and after calculating the values in the group by operation, we want to filter out something, right? We want to filter out those kind of chunks where they are not following any specific condition. So along with the group by clause, we can use having clause as well. And having clause doesn't have any individual identity. It cannot act like a where clause, which is where clause, when we talk about, it is actually like a independent entity. But this having clause can only be used along with the group by, not individually. So let's try to write some query where we are performing some operation, right? Here we can see our entire data set. So what kind of query we can apply? So let's say we are trying to calculate the strength of the employees in each office, and we are only interested in these offices where the strength of the employees is more than 3 or equivalent to 3, not less than that one. Okay, so how we can write this particular query? If I paste it here, this part which we have already written above, and here we will simply apply this condition. Okay, we are only interested in these kind of records. So here this query will be exactly same, office code grouping we have done. After that we are counting the number of employees for each office code. But here what we can do, after this group by operation, we can write this having keyword and we can apply this condition. Count star means whatever count which has been calculated for one individual group, we are checking its value whether it is matching with our threshold value or not. That is count star greater than equals to 3. Okay, this is the thing which we wanted to evaluate. Now if I run this query, okay, here we can see only 2 office codes, 4 and 6, because these are the offices where employee strength is equivalent or more than 3. So now let's look at the last operation of our tutorial video, which is also the most important, the very important, the joins. So why joins are actually important? As I already mentioned in the beginning, the fundamentals of the keys, primary keys, foreign keys, because data analytics is not only about one table where you have everything and you are doing everything. It is always about creating a normalized database, and that will definitely have multiple tables. So we will be having multiple ways, different logics, different conditions to bring data together so that final informative report can be generated. Okay, so that is why this join operation is something which will be very helpful, and there are different type of joins available. The most important ones are like inner join, left join, right join, also full outer join. So one by one, first I will explain how inner join works. So if we go back and try to just display the output for employee and the offices table. So select star employees. Okay, here if we look at this data, we can see office code which was of a string type, right? These values are present here. Now if I query this data, the offices, so here we will also see the full detail for each office based on the office code column, right? So definitely this office code is the important column based on which we can join these two data sets together. So first type is the inner join. Inner join means when we are using few key attributes for the join operation, so in the final results only those records will be present which are having the same values. If there is any mismatch for the values, those will not be included in the final result. So if you just want to imagine a Venn diagram for it, if you have two sets of number, so whatever will be the overlapped part or the middle part, that is the section we will be getting in the inner join output. So let's try to write the query for it, how we write the proper syntax to perform the join operation. So here what we are going to do, we are going to involve two tables, and there is a concept of giving alias name to the tables as well. How we can do that and why it is important? Because in the final select statement, we might be interested in few selected columns from table A, table B. So we should have some reference name or alias name which can be used here. So let's say employee table, we will give a alias name like EMP, and for offices table we will give a alias name OFC. Okay, so that is why first I am writing the complete inner join part, and at the end I will be writing the columns in the select statement. So select from employees table, and the alias name is like EMP, just one single space, and after that whatever you are mentioning in front of the table name, that will be treated as a alias name. So from employees EMP, inner join offices OFC, and after that we need to mention this on keyword, because when we are joining the two data sets, we need to mention which column we are going to use. Okay, and for this one, from the EMP table, there we also have a office code column, and we also have this column in the offices table. Okay, so the same column, you can see we are trying to join these two tables with the help of office code column, and even this is not necessary that column name should be same. Column names can be also different, but with the proper aliasing name we need to provide this referencing that in which table these two columns are present. So this is the condition for inner join, and as I said, now I will mention proper column names. So here what we want to do, we want to select all the columns from the employee table. So it will be EMP dot star comma OFC dot start. Okay, now you can see this is the complete statement or syntax for our inner join. Now if I execute it, okay, in our output you can see there is a very big table which is involving all the columns from both of the tables, because we have done this kind of select emp dot star ofc dot star. But the interesting thing we can see office code, right, the output which we are getting in our final result, the values for office code 2, 4, 5, 6, 7 is present, right. If you remember, in our office code table itself there was a code for 1, value 1, means there was one office where the code was assigned as 1, but for that particular code there was no record in our employee table. Here, using the delete command, we deleted all those employees who were belonging to office code 1, and that is the thing which I want to highlight, that if we perform the inner join, those kind of records will not come in the final output. Now talking about the left join, this is also another version of this inner join kind of thing. So here what will happen, again try to imagine the same Venn diagram, two data sets, and if you are using some on condition and there is a table which is on the left side, when we perform the join operation there will be a table on the right hand side. In case of left join, whatever records are getting matched properly, they will definitely become the part of final output. But let's say there is any specific value which is present in left hand side table, but there is no specific match for that one in the right hand side table, then in that case we will be getting the output from the right hand side table, but those values will be populated as null. Okay, so how we can change our query? Simply we need to change this keyword from inner to left. All right, so if we execute it, right, we are getting the data. But if you remember, in our employee table ultimately there were all such type of records for which match is definitely present in the office code table, right. So for an example, if we try to explicitly insert few records in the employee table which are not present in the office code, let's say office code 2030, we are maintaining entry in the employee table but those are not present in the office code, then this left join will give us the output, but the right hand side table column will not be populated. They will always be populated as null. Now if we talk about the last operation, which is the right join, for that one you can just treat it like a reverse of left join. So whatever thing were happening with the left hand side table in the left join, same thing will happen with the right hand side table in case of right join. So if there is a match, obviously those records will become the part of final output, but if there is a mismatch, then the records from the right hand side table will be there, they will be completely populated, but the records from the left hand side table will not be populated because there was no match available for that value. So how we can do that one? If I write this left to right and if I execute it, in this case we can see this one, this record is something which you need to focus on, because since we deleted all the employee records which were belonging to office code 1, that was the reason in employee table there was no employee record related to office code 1, but this entry is present in the offices table and we are doing a right join. So this is the right hand side section which is coming from offices table. It is completely populated, right? You can see this is completely populated, but the data which is coming from the left hand side table, this is completely null. And why it happened? Because there was no match for office code 1. So that's what I had for all the SQL basics command, and I'm pretty sure this practical implementation will give you the crisp idea how to set up this whole MySQL environment in the local machine system and how to perform all these basic operations with the dummy data. And as I said in the beginning, this entire code piece will be provided to you in the GitHub repository. You can find the link in the description and you can also practice the same things. So that's what I had for this video. I'm pretty sure now you have a clear idea how to use and apply basic SQL commands, and the code snippet and the queries which I was writing, you can also use it and try to implement it practically. The GitHub repository link will be provided in the video description. And if you find this video informative, then hit the like button, and if you have any doubts, any queries, then feel free to put it in the comment section, and don't forget to subscribe Scalar's YouTube channel for more such insightful content.
Did you know that subqueries and window functions are the two most important interview questions? Hello, my name is Sumit Shukla, and in this particular video, I'll be helping you to understand subqueries and window functions with example. But before we start this video, don't forget to subscribe to our Scalars YouTube channel. Let's get started. Now let's talk about window functions. Now this is something which makes your life easy and also add more functionalities while you are writing SQL queries. So let's try to first of all understand why we need a window function. I will try to explain this particular technique, which is window function, by taking one example. Let's say we have employee ID. So I'm creating a sample table. I'm having a name. I'm having salary. Then department ID, and we are having some records. So here I'm having 01, 02, 03, 04, 05. So we have 5 employees, and I'm taking some sample names: AA, BA, CK, DM, NK. Random salaries 10, 12, 11, 15, 10. Random departments D1, D2, D1, D2, D3. Now if I ask you to find out department wise average salary. Now in order to answer this question, we will be using the technique of group by. And if we try to generate the output, it would look something like this. We will have a output table with department ID and average of salary. And since we are having 3 departments, I will have 3 records over here: D1, D2 and D3, with D1 average being 10.5, because here I'm having one entry with 10 and 11, so 10 plus 11 divided by 2. Then D2 we have 12 and 15, so that is 13.5. 12 and 15 is 27, and D3 we only have one record, so 10. Now this is what I will get as an output when we try to find out the answer for this question: what is department wise average salary? Now this particular output is basically generated after applying group by. We have used the command group by, and this is the aggregated table which we have obtained as an output. But what if I do not want this table as an output? This is a separate table that is generated after applying the group by command. I do not need this separate table. This is a separate table. I do not need this separate table. So what I need these average values as a part of same table itself. So let's say I need average of department ID over this column itself. So corresponding to D1, I'll get 10.5. Corresponding to D2, I'll get 13.5. D1 10.5, D2 13.5, D3 10. And this is the additional column that I wanted to generate. Now how this is possible? This is possible by using what is known as windows function. Now window function is something which we apply in two stages or maybe two steps. The very first step is windowing or partitioning. So what is windowing and partitioning? Let's try to understand it with an example. So my step number one is I will create windows. Now here we will keep the example same. My objective is to generate this additional column which is department wise average salary. So while we are creating windows or partitioning the data, we will partition the data according to the department ID. Let me show you this. So we have employee ID, we have name, we have salary, we have department ID, and let's generate the records. So 1, 2, 3, 4, 5. So here now my objective is to create windows. So all the records according to department number 1, I'll keep it together. So 01 AA, 10 Z1, 03 CK, 11 D1, then 02 BA, 12 D2, then 04 DM, 15 D2, and finally 05 NK, 10 D3. So here if you closely observe what I have done, I have created some windows or partitions. So this is my window number 1, window number 2, window number 3, or if I have to highlight the partition, this is partition number 1 and this is partition number 2. So we have all together 3 partitions, 1, 2 and 3. Now this is my step number 1 or stage number 1. So I'll write windowing over here, windowing, or it is known as partitioning, and I'll write 1 over here because this is stage number 1. Now once I am done with creating partitions, my next step is to apply aggregation function on each window. So my objective is to generate average of salary department wise. In the second stage, what I'm going to do, so again I will have all the columns, employee ID, name, salary, department ID, and let's generate the record 1, 2, 3, 4 and 5. Again 01, 03, 02, 04, 05, AA, CK, BA, DM, NK, 10, 11, 12, 15, 10, finally D1, D1, D2, D2 and D3. Now here what is my objective? My objective is to find out department wise average salary. So now on each of these salary window or salary partition, so we are going to apply the average aggregation function, average of salary. So I'm basically going to perform aggregation over each partition, aggregation over each partition. Now here I am going to apply the aggregation function which is average. So here we will apply the aggregation function average. Here also we will apply the aggregation function average, and here. Now if I apply, I'll get the value 10.5 over here, 10.5 over here, followed by 13.5 over here, 13.5 over here, followed by 10 over here, and this is my new column which is average department salary. Now here we are not just limited to average. We can have multiple functions. We can have almost all kind of aggregation functions over here. We can have sum, we can have count, we can have minimum, which is min, we can have max. So all these aggregation functions can be applied over here together with the average. These are my aggregation functions. Now how we can write the query for this? So this was my stage number 2. How we can write the query? In order to write the query, we will again follow the 2 steps which we have discussed. So the query looks something like this. We need to select asterisk. Asterisk means I am interested in getting all the columns. So asterisk, all the columns, followed by comma. I need average of salary. I need to apply average of salary aggregation function over the window or over the partition which is partitioned by, so over partition by, the column name is department ID as average underscore dp underscore sal from the table employees. And this is how simple it is. Those who are worried about window function can see how easy window functions are. So let me just tell you again what we have done. Here you can see that we have applied average of salary, which is my aggregation function, over. We use the clause over to generate a window. So I'm saying generate a window, which is generated using the clause over. The window is partitioned by department ID, and this is what we have done, right? As average department salary. So this is the name of the new column from the table employees. So here we have applied 2 steps, step number 1 and step number 2. If I try to map the steps in my query, this is my step number 2 and this is my step number 1. Right? Simple. So let's now take one example to understand how we can apply window functions on a sample database. Now here I'm having a database named HR, and here you can see that we have following tables such as countries, departments, employees, job history, location and region. Now if I look into my employees table, so we'll write select a star from the table employees underscore data. Now here please remember one thing, that I have already activated my HR database. So that is the reason I was able to query the table from the HR database. So here you can see that we have department ID and the salary of various employees and their employee ID. Now let's say I wanted to generate the following output. I need the full name of the employee, followed by his or her salary, followed by his or her department ID, and finally followed by the average department salary. Now here please remember one thing. If I need the data of all the employees, I cannot do that using group by, because group by returns you the aggregated table. Let me show you one example. Let's say if I have to find out department wise average salary, I can simply say select department ID, comma, average of salary from the table employees underscore data. Now if I execute this, we have to also group the data. So group by department ID. If I execute this particular query, I will get department wise average salary. But if I try to add, let's say, first name, I'll get error, because that is not possible. You can see that we will be having an error, and the description of the error is that we haven't not added this particular column in the group by clause. So you cannot get the non-aggregated entries. You have to put all those columns in the group by statement. It is impossible to generate the following data or the following result using group by. Now that is the reason we have learned about window functions. So let's now try to generate this output. Let's first of all select first name. So here we will use the concat function. Concat first name with the space with last name as full name. Then we need salary, comma, we need department ID, and then I will apply the window functions. So we need average of salary over partition by department ID as average department salary, and here we have to just write from the table employees underscore data, and if I execute this we have the result. So this person so here you can see that we have two employees working in department 20, Michael and Pat Phi, and their individual salaries are 13,000, 6,000, but their department average is 9,500, which is the same entry for both of them. So this is how we can simply apply window functions. Before I move to the next topic, I just want all of you to concentrate on this particular result. By default, you can see that within each window, the data has been ordered according to the department ID. So if you closely observe, the very first row I'm having department ID as 0, which is the maybe the minimum department ID, and the last row is 110, which is the maximum department ID. Now since I have not added any order by clause within the window functions, the results are automatically sorted according to the ascending order of department ID. Now how we can change this and how we can apply more aggregation functions with order by, we will talk about this in the next slide. So let's now understand rank function. Rank is basically a aggregation function that works with the window function. But the reason we are trying to explain it in a more detailed way is because the way we create the window is little bit different from the regular window. So let's take one example. Let's create a sample table. Here we have employee ID as one of the column or maybe the field, then followed by name, salary, and department ID. Now let's create some sample data. So row number 1, record 2, record 3, record 4, record 5, 01, 02, 03, 04, 05, 06. Again, sample names AA, BA, CK, NM, TA, DT. Salaries 10, 15, 12, 11, 15, 11. Random departments D1, D3, D1, D2, D2, D3. Now, what is the objective of having a rank function? So let's say I wanted to generate an additional column over here. Let's say the name of the column is rank underscore, and I wanted to rank employees according to their salary within their department. So if I look into the department number 1, this is the employee in department number 1 followed by this employee. But among these two employees with the employee ID 03 and 01, the employee with 03 employee ID is having a salary of 12, and then 01 is having a salary of 10. So this person will get a rank of 1, while this person will get a rank of 2 within their department. Similarly, department number 2, this person will get a rank of 1, this person will get a rank of 2. Similarly, department number 3, this person will get a rank of 1, this person will get a rank of 2. Now, how we can generate this column or a field using window functions? So again, we will apply the window function as regular in 2 steps that we have learned. So first of all, we will apply windowing operation. I have to again generate this column, employee ID, name, salary, department ID. And now while I am creating the windows, I will make sure that within each window, the data is ordered according to the salary column in descending order. Now please carefully observe. I will start from department number 1. So 0, 0, 3. The reason I am putting this employee 03 as the first row or the first record is because among these 2 employees who are working in department number 1, this person is having a salary of 12 while this is having a salary of 10. So since I have to make sure that within each window my data is ordered according to the salary in descending order, I will place employee number 03 at my first row followed by 01 in my second row. Again, I'll do the same thing for other departments. So 05 TA, 15 D2, and then 04 NM, 11 D2. Similarly for D3, 02 BA, 15 D3, and 06 DT, 11 D3. Now here carefully observe what we have done. Within each department or within each window, so this is my window number 1, window 2, window 3, I have ordered my data according to the salary column in descending order. If you closely observe these 2 values, you will understand what we have done. And now what we have to do, we have to apply the aggregation operation as my step number 2. So let's move to the step number 2. So this was my step number 1. This is my stage number 2, where I'm going to aggregate the data, and the aggregation operation that we will apply is the rank function. So let's generate the stage number 2 output. Employee ID followed by name followed by salary followed by department ID and the additional column, which is rank. Now again we have 6 entries or 6 records. So 01, 02, 03, 04, 05, 06. So here we have 03, 01, CK, AA, 12, 10, D1, D1, and this will be rank 1, rank 2. And other department 04, TA, NM, 15, 11, D2, D2, rank 1, rank 2, 02, 06, BA, DT, 15, 11, D3, D3, 1 and 2. Now if you carefully observe what we have done, within each window I have ranked the employee with their according to their salary in the department, and this is what the rank function is. Now let's first of all understand how to write this query. So we start with select. We need to select asterisk. Asterisk means I'm interested in selecting all the rows and columns. Asterisk. Then I need to apply the rank function. So rank round brackets over partition by department ID and order by salary in the descending order. So this is very important. I have to order my data within each window according to the salary column, but in descending order, so that within each window I can get the first row as the highest salaried employee, followed by second highest, third highest, and so on. And from the table employees underscore data. So this is how rank function works. But there are some more functions which are available in SQL. So we have functions like rank, dense rank, and the last one is row number. Now these three functions are very much similar to each other. Let's understand the difference. Take one sample data. So here I'm having a salary followed by how the rank function will work, how the dense rank function will work, and how the row number will work. So row number के लिए I'm writing row underscore n, and let's create some rows or the records. Now please consider this as one window. This is one window. Within this window, I'm having a person with salary of 100, 98, 98, 95, 92, and 80. Now, how rank function will behave in this case? The person will get a rank of 1, 2, 2. Now here, the rank function will skip the rank and you will get 4 over here, followed by 5 and 6. What dense rank will do, it will not skip any rank. So you'll get 1, 2, 2, and 3, then 4, then 5. And row numbers are just raw numbers ranging from 1 to n. So 1, 2, 3, 4, 5, 6. So this is how we use rank functions, and this is how we can write the query for the rank functions in SQL. So let's now take one example to understand how we can use rank functions with window. So here we will look into the employees table, which is named as employees underscore data. Now let's say I wanted to find out that within each department, what are the various employees and their ranks. Rank according to their salary. So we will write select. I want all the columns. You can also select few columns like first name, department ID, salary. It is up to you, but I am selecting all the columns, followed by the function rank over partition by department ID. And please remember, it is very important to write the order by clause. Order by salary column in the descending order as RNK. RNK means rank from the table employees underscore data. Now here you can see that we have the following ranks generated. So let me expand this quickly for you. And here you can see that for department number 30, we have the following employees and their corresponding ranks 1, 2, 3, 4, 5, 6, because all of them are having different salaries. Now let's quickly also check out other functions like rank, dense rank, and row number. So dense underscore rank, and for the window function creation would remain the same. So I'll quickly copy this, put it over here. I'll copy this put it over here and I'll call this as D underscore RNK. Similarly, we will use row number and I'll call this as RN, and let's run this. Now here we can compare all the three functions. So let's navigate in this particular row, or maybe row number, department number 100. Here everyone is having the same salary, so no difference. Okay, let's focus on let's focus on department number 60. Now here you can see that I'm having two employees with the salary 4,800, 4,800. So here rank function has given 1, 2, 3, 3 and has skipped the fourth rank, so I'm getting 5. Here the dense rank function has given the rank 1, 2, 3, 3 and the fourth rank also. And here row numbers are just the raw numbers 1, 2, 3, 4, 5, which is basically the number of rows in a particular window. So this is how you can use the various ranking functions together with the window functions. Let's now understand what is subquery and how we can write a SQL query using subqueries. So first of all, let's take two examples. Let's say I have to find out. So I'm writing down the question and let me increase the so I'm writing down the question. Find the average salary of department or the executive department. Now, how we can answer this question? Here I'm having two tables. One is the employee table, which you guys can see over here. In the employees table, we have employee ID, first name, last name, and so on with the department ID. But I do not have the department name. Now, where I can get the department name? In the department data table, we have the details. So if I look into the department data table, select a start from department underscore data. I'll get the details of all the department names together with their department ID. So basically what we will do, there is one way to join these two tables and then apply the filter. So let's take the traditional way, or maybe the most simplest way. First we will join the two tables and then we will perform the filter. So let's join the two tables. Select a star from the employees data table and I'll call this as A. Inner join department data table and I'll call this as B on A dot department ID is equal to B dot department ID, because department ID is basically the common column, the primary and the foreign key combination between both the tables. And when I do this, you can see that I'm having the joined table. Now I have to filter this where the department name is executive. So I'll write where B dot department name is equal to executive, and we are done. Now these are the entries wherever the department name is executive. If I want the average salary, I'll quickly change the star and I'll write average of A dot salary, because in the table number A, which is over here, I am having the salary column, so I get the average salary. But is this the best way to solve this question? Or maybe is this the best way to write down this query? Certainly no, this is not the best way, and you should not be joining the tables. The better way of doing this thing is to write down a subquery. Now what I am going to do, I will be using the department data table to find out the department ID where the department name is executive over here. So let's write down this query. Select star from department data where department name is equal to executive. And once we execute this, I have missed a is equal to sign. When I execute this, here we have the department ID 90. Let's select only the department ID. Department ID. So I'm getting department ID as 90. Now I'll be using this value to filter the employees data table. So I'll write select star from the table employees underscore data, where department ID is equal to, and instead of writing 90 manually, I will provide this complete query, the inner query, the below query, as a subquery. So this query, which I have written over here, which is returning me the output 90, which is the department ID of the executive department, I'm using this output to filter this particular data, the employee data table. And let's execute this. And you can see that I'm having all the employees from department 90. Since I need the average of salary, so I'll write average of salary, and we are done. Right? So this is how we write subqueries. Now let's try to understand when to use a subquery versus when to join two tables. This is a very tricky situation for most of the students to choose whether to join or whether to use a subquery. Now it is not that difficult. Let me explain you with an example. So we will take two questions. The first question is find department name wise average salary. Now here, how my output would look like. Since I need department name wise average salary, I'll have two fields or two columns. One of them which will be department name, followed by average of salary. And here we will have the department names and we will have the average of salary. Now, if you guys closely observe, this particular column, which is department name, is from the table department data. And this particular column, which is salary, is from the employees data table. So here in the output of this query, is having columns or fields from two different tables. So the output is having fields from two different tables, right? Now let's take another example. Find average salary of executive department. Now here, if I ask you how the output would look like, it will be a single value, just average of salary, right? And we will only have one single answer. Let's say this is the average salary. But if we write down the query, here I will be using the executive department as a filter, right? So when you are having the output where you have the column or the field only from one table, which is employees data, I will not be joining the tables. So the learning from here is, when you have output which involves field from multiple tables, we have to join those tables. Join. We have to apply the join. We cannot generate this kind of output without performing join. But if we have the output from a single table, or maybe if we have a particular field in the output from a single table, we will use subquery. And this is the simple trick you guys can use to decide whether to use a subquery or whether to use a join. Let's now look into one example to understand when to use a subquery versus when to use a join. So here we have already solved this particular question using the subquery, where the objective was to find out executive department average salary, or maybe the average salary of the executive department. Now if you closely observe, here we have used the filter of the executive department in the subquery. So here we do not need to join the two tables. But let's say I need to find out department name wise average salary. So my objective is to find out department name wise average salary. So the very simple way of doing this thing is, we'll say select, first of all I'll join the two tables. So select a star from employees data A, inner join departments data B on A dot department ID is equal to B dot department ID. And here we have joined the two tables. Now my objective is to find out department name wise average salary. So department name is in the table B, so I'll write B dot department name. Then I need average of A dot salary, and here I have to write down group by clause, group by B dot department name, and we are done. Now here you can see that we have department name wise average salary. So this is quite easy. When you get into the practice, you will be easily able to segregate when to use the join or when to use a subquery. Now there are some rules which you have to understand while writing a subquery. So let's quickly go through the rules. The very first rule is subquery must be enclosed within parentheses. So let me take this previous query and we will try to run it without parentheses now. So I'll remove the parentheses over here. Now you can see that I have got a cross mark over here, and if I try to execute it, I'll get an error saying that you have some error in your SQL syntax. You can see over here. So this is the rule number one. We have to place the subquery always in the parentheses. The second clause is a subquery can only have one column in select clause unless multiple columns are in the main query of the subquery. Now what is the meaning of this? So let's again take this example. Now here if you closely observe, here I'm having department ID and I'm comparing my department ID with this particular column which returns one value, which basically mean I am comparing one value with one column. One value with one column. That's how the comparison is made. But if I put two columns over here, let's say employee ID also, that is something which will give you error. You can see that we have a cross mark because the mapping can only happen 1 to 1. That's what the second rule while you write a subquery. Let's now understand the third rule of writing subquery. The between operator can be used with the subquery. Let me give you one example to understand this. Let's first of all find out the minimum and the maximum salary of employees working in department 30. So select max of salary from the table employees underscore data, where department ID is equal to 30. Now this will return me the maximum salary of department 30. Let's quickly copy this and convert this query as minimum salary. So here I'm having another query. Now I want all those employees who are earning between these two salaries, the minimum salary and the maximum salary of department 30. So we can write a subquery, we can write a main query which can accommodate these two subqueries using between clause. So select a star from the table employees underscore data where the salary between, I want this salary, so between the minimum salary, I'll put this in round brackets because that is the rule of subquery, and the maximum salary, and I'll put this one also in the round bracket, and finally a semicolon, and we can execute this. Now here you can find out that we are having all the employees who are earning between these two salaries, the minimum salary and the maximum salary of department 30. So that was our third rule. Let's understand the next rule. Now for the next rule, I do not have any demonstration for you, but the rule is blob, which is binary large object. So whenever you preserve images or the data which is in binary, because if you remember, the image data comes in a binary format, ones and zeros. And when you preserve this data in database, it is preserved as blob. So it is impossible, or maybe it is not possible, to use subqueries when your column, the reference column, is blob or C blob or N blob or B files. These are the file formats, or maybe the column, the data types with which you cannot use the subquery. Now these are the some rules which we have to keep in mind when we are writing subqueries. Let's now understand the difference between non-correlated subqueries and correlated subqueries. To understand the correlated and non-correlated subquery, we will take very simple example. Let's say I wanted to filter all those employees who are working in executive department. We have already seen the example. So let me write down the query for it. Select a star from employees data where the department ID is equal to, and here we have the subquery, select department ID from the table department data where department name is executive. So here, if we closely observe, there is no connection between these two subqueries. This is an independent subquery and this is an independent subquery. If I select this subquery, so in SQL, if I select this subquery and if I execute only this query, it will run independently. And this is what is the example for non-correlated subqueries, because there is no interaction, or maybe there is no dependency between these two queries. So non-correlated subquery. Now let's understand correlated subquery. In order to understand correlated subquery, I will be required to create a dummy table. So now let's understand the correlated subquery. In order to understand correlated subquery, we will take one example and I'll be required to create one table which is having three fields: employee ID, name, and salary. I'll create the same table for 2 times because we have to compare the values. So it is the same table, but I'm creating for 2 times. Let's add some random data, and the same for here also. So 1 2 3 4 A B C D, and similarly over here 1 2 3 4, then A B C D, and here some random salaries. The same salary over here also. Now let's write down the query to understand what exactly a correlated subquery is. So the correlated subqueries looks something like this. Select, I'll call this table as E while this table as P. So I need E dot name comma E dot salary. From the table, let's assume that the table name is employee. So from the table employee, followed by the where clause, where 2 is equal to, and then we have written a subquery. Select count of salary from the table employee P. Now this the same table, but we have referred it for 2 times with alias E and P. So from employees P, and there is a condition where P dot salary is greater than or equal to E dot salary. Please remember, we'll be first executing the inner query E dot salary. So this entire row will be taken, and now we will compare this salary, which is P dot salary, whether it is greater than or equal to E dot salary or not. Yes, it is. So we'll count. So because we have to count, so count will become 1. Then I will compare this one, because I have to check how many salaries are there in my table P which are greater than this particular salary. So 6,900, is it greater than or equal to 7,000? No. 5,000, is it greater than or equal to 7,000? No. 2,000, is it greater or equal to 7,000? No. So I'll get the count here 1. Now 1 is not equal to 2. So this is not meeting the condition. So we will not get this row as an output. Now I have to move to the second row. Now my entry value is 6,900. So here I'll get 6,900. Now I will compare whether 7,000 is greater than or equal to 6,900. I'll get 1, yes. Whether 6,900 is greater than or equal to 6,900, yes. So instead of this 1, I'll get 2. Whether 5,000 is greater than or equal to 6,900, no. Whether 2,000 is greater than or equal to 6,900, no. Now here I'll get 2. So 2 is equal to 2. Condition has matched. So my output will be this particular row. So my output will be E dot name, which is B, and salary, which is 6,900 as my output. Now this particular query is helping us to find out the second highest salary. Now there are multiple ways to find out second highest salary. You can use limit, offset, but this is the way in which we can find out second highest salary using the concept of correlated subquery. Here what is happening, until and unless my second or the internal query is not executed successfully, my outer query will not execute. So there is a dependency between the internal query and the external query, and that is the reason this is known as the correlated subquery. So with this, we come to the end of this video. We hope that you guys found this video really helpful to understand subqueries and window function. Before you end this video, please like this video, share this video with your friends, and don't forget to hit the bell icon so that you never miss any update from us. MySQL, MS SQL, Oracle, PostgreSQL, Are you guys confused regarding what is the difference between these platforms and when to use which platform? Hello, my name is Sumesh Shukla, and in this particular video, I'll be clearing your confusion. In this particular video, we will first understand the concept of database, the difference between client and server, and what exactly is SQL. Then we'll be trying to understand the difference between various SQL vendors. Before we start this video, don't forget to subscribe to our Scalers YouTube channel. Let's first of all understand the problem, why RDBMS was invented and why people need RDBMS. So we will start with the example of a multinational company. Since we all are very much aware about companies like Amazon, I would take the example of Amazon. So here we have the company Amazon. Now, let's say let's say the company Amazon has recently started, and as of now, they are using a traditional storage system. Now, what is traditional storage system? Let's say the company is preferring to use Excel files to store their data, maybe PDF files, maybe pen drives, or maybe hard paper document. Now these all technologies, or maybe I would say the storage options, are known as traditional storage system. Now, if Amazon is using these traditional storage system to preserve their user data, or maybe to preserve their data about everything, about their orders, about their customers, about their payment methods and everything, what all problems the company would face? And you can pause the video and can comment your answers. Maybe you can let us know what all problems the company would face. If we talk about the major problems, the very first problem is the data size is huge. As you guys already know that data is humongous. So let me write it down. Data size is huge. And the data is growing at an exponential rate. So every day, Amazon would have a bulk of data to preserve, and these traditional storage system comes with a limitation. So they will not be able to accommodate everything in these traditional storage systems. So that's a very general problem, the very first problem that they would face. Now the second problem is with the management. As the data is growing exponentially, managing all these Excel files would be a very great problem. Where to keep all these files? Where to preserve them so that, first of all, it is secure, it is not getting distorted, it is not getting exposed to some of those people who are not authorized to use them. So there are a lot of problems and challenges to manage all these files. Now the third problem that the company would face is security, as I was talking about in the last point. But the major problem that the company would face is regarding the same view of the data. Now what is same view? As you already know, Amazon is a multinational company. Multinational means they have offices across world. So let's say Amazon is having their office at USA. Now here we have the USA office, and here we have the India office. Now let's say there is a person, let's say this is me, Sumit Bhaiya. So let's say there is a person, Sumit, who is sitting in USA office working on a particular project. I'll name this project as P1. Here we have another person, and her name is Shreya, and she is also working on the same project P1. Now they both need to work on the same data file. So what Amazon has done, we have to assume right now that Amazon does not have any technology to make the same data available to both of them, or maybe the same data is accessible to both of them. So what Amazon has done as of now, they have provided the copy of the same file. So here we have the main file. I would call this as main file, and one copy is provided to Sumit. So I will call this as C1. Another copy is provided to Shreya. I'll call this as C2. Now, what is the problem? The problem is any changes made by Shreya in her copy, which is with her, the C2 file, will not be replicated or will not be available to Sumit in his file, which is C1. Similarly, if there are any changes made by Sumit, it will not be visible, it will not be available to Shreya. So the analysis that will be done by Shreya and the analysis that will be done by Sumit will be two different things, because they have not been provided with the same version or the same view of the file. And that is the major problem. How to make the same data, the same view of the data available to everyone who is trying to work on the same file. That's very important problem. The second problem is with the management of the data. How to logically arrange the data. So let me call this as problem number 4, the problem that we have just discussed, the same view problem. The same view problem. And I would color it in red so as to mark it as a very important and maybe the very difficult problem to resolve. Now, coming back to the last problem, like there are multiple problems actually. We cannot talk about everything. So here we are trying to discuss the most difficult problem in the sequential order, starting from very difficult to least difficult. So the fifth problem is logical collection and arrangement of the data. Logical collection and arrangement of the data. Now for this also I will use a red color to mark it as very much important or maybe most difficult problem to resolve if the company wish to use traditional storage system. Now before I move forward, let me just recap. Here all the problems that we are right now talking about talks about the traditional storage system. If a company, any company prefers to use these traditional storage systems, what all problems the company would face. So when it comes to logical collection and arrangement of the data, let's say, so Amazon has multiple business, right? Let's take one of the business, which is e-commerce. Now you guys already know that in e-commerce, various customers would place various orders. So we have the orders data. Then each order would have the customer's data. So which order was placed by which customer. So we have customer's data over here. Then we will have the customer details like what is the name of the customer, the email ID, the password and mobile number and other customer centric information. Then each order will be associated with a product. Now which product was ordered? So let's say product number 1 was ordered and this customer ordered product number 1. So there will be product details. Then each product will be associated with a vendor. As you guys already know that Amazon is a marketplace which connects various vendors to the customers. So each product will be linked to the vendor who has placed this product in the website. Then we will have the vendor centric information like who is the vendor, how many orders or maybe how many products he has placed in the website. We will also have the delivery partners. So each order will have the delivery partner details. Now here you can see that we are creating a mesh, and then it is like a network where each data point is connected to another data point. If I try to preserve the data in this format using Excel files, using PDF files, using pen drives, I would certainly not be able to do it. The reason is we do not have any mechanism which can let us preserve the data in this kind of format. And that is what the fifth problem is: logical collection and arrangement of the data. How to logically arrange this data in such a way that it is easy to input and it is easy to retrieve the data. Because if I'm trying to preserve my data, my objective is not to just preserve. My objective is also to retrieve that information so that I can perform the analysis and find out some interesting insights from the data. And that is why any company preserve the data, so that later it can be utilized to find out interesting information, right? So these are the major problems that was present before the invention of RDBMS. Now, how these problems were resolved? In order to resolve these problems, the technology that came into existence, and this technology happened to be invented in 1970. I will tell you the history of how this technology was invented, who invented, but right now let's try to focus on what this technology was. The technology was named as RDBMS. It is named as Relational Database Management System, RDBMS. Okay. Now, RDBMS as a technology comes with two components. The very first component that is a part of RDBMS is known as the server, and the second component is known as the client. Server and the client. Now let's first of all understand what is a server. Server is basically the central storage of the data. Now please remember one thing: the explanation that I am making right now is according to the latest architecture of RDBMS that exists today. So I'm not talking about 1970s, because in 1970s the technology was different, the architect was different, and whole technology and whole process was different. So right now we are talking about the latest technology and how RDBMS systems work today. So right now today we have a server and we have a client. Now what is server? Server is basically the central storage of the data. So this is a server and this is a central storage. So I'll write central. Now, if you guys haven't looked into any kind of server, you guys can quickly check out Google Data Center, and there is a video which will help you to understand how a Google Data Center look like. But I have some pictures over here which can help you to understand. So this is how a data center or maybe a data warehouse looks like. You can see that over here I have a lot of boxes. Now these boxes over here, these boxes are known as racks. So here we have one such rack. This is a rack. And each rack is having a lot of computers connected together to create a huge network of storage plus processing power. So here you can see that each entity over here, so this is 1, this is 2, this is 3. Let me write it over here. This is 1, this is 2, this is 3, and so on. These are basically individual computers, and all of them are connected together. You can see that all of them are connected together with these overhead wires, right? When they are connected together, they create a huge network of storage space and processing power. And that is what is known as a server. Now assume that you have a central room where you have so many computers connected, you have a very huge storage space, and you can connect to that storage space using your ID and password. That is what a server is. So this is a centrally located storage system present anywhere in the world. Right now, Google operates so many data centers across the world. Even IBM has a data center. Companies like Amazon has a data center, and there are multiple data centers present across the world. So we can assume right now that we have one such data center of Amazon, which is centrally located in, let's say, USA. Now, here I am sitting in India, and here is my laptop. Now, in order to connect to this particular server, I need a software on top of which I can enter my username and password, and I'll be able to connect to the server. So I need a software that can run on my laptop. So let's quickly create a interface of software. So this is my software. Now this software will connect to the server. This software is known as the client. So if I talk about client is basically the software or the UI. It is also known as GUI, graphical user interface. So I'll write GUI. So it is GUI, graphical user interface, that runs on the user's laptop. Now, on this particular software, which is client, the user can input his or her credential, and that will let the user connect to the server. Once the server is connected, once the user is connected to the server, the user can communicate the requirement to the server that, hey server, I need XYZ details, or maybe, hey server, please return me the top 10 customers who has made the purchase, or maybe, hey server, please return me the top 10 products that have sold yesterday. But the problem is how we can write this, or how we can talk to the server, how we can communicate our requirement to the server. In order to solve this problem, the language was created, and this language is known as SQL. So please remember one thing, SQL is not a programming language, it is a communication language. SQL is used to build a communication between the client and the server. So whatsoever information I need from the server, I will write down in the SQL format. I will write down in the SQL query that will be communicated to the server. See, server will process it and it will return it to me. So SQL comes over here, which act as a communication language between the user and the server. So let me write it down. SQL, which stands for a structured query language, which is a communication language that act as a bridge between the user's requirement, which he or she will write down in the form of SQL query, and the server. So this is basically a language that is happening between these two components. Now, the first problem is resolved, that okay, we have the central storage, all the data is present in the central storage. So anyone who wanted to query that data or maybe check out that data can log in and can check it out. So my problem number 4, which was over here, is resolved. So I'll write tick, it's done. But what about this problem, 5th number problem? how the data is logically arranged. Now, this is something that is what the architecture of RDBMS is. If we try to understand the architecture of RDBMS, it is very simple. Let's understand this within a very layman example. Over here, okay, let's say Amazon is having multiple business, and it is having multiple business actually. So I'll write down e-commerce over here, e-com, and then Amazon AWS, then Amazon, let's say Amazon Entertainment, ENT, then we have Amazon Pay, the financial services. Now, within each of these business, Amazon will be having multiple data sets or maybe multiple sources of the data which the Amazon has to preserve. If I take a very simple example, let's say I'm having some files or maybe I'm having some photographs. Let's say I have some 1,000 photographs, out of which some photographs belong to me. So Sumit's photograph. Some photographs belongs to my girlfriend. So Sumit's GF. Some photographs belongs to my parents. So Sumit's parents. Some photographs belongs to let's say my father, or maybe let's say my brother. So Sumit's brother. Now let's say this is my laptop. So what is the best logical way to preserve all this data, all these files, all these photographs into my laptop? And let's say I'm talking about the D drive of my laptop. Now, if you guys think about it, the best possible way is to create folders. So I have created folder A, folder B, folder C, folder D. And I can place all the photographs of myself in A, followed by all photographs of girlfriend in folder number B, then folder number C, and then folder number D. Now this is the best possible way to logically arrange this data in my laptop. Now the same architecture or maybe the same logic is used by database. In your RDBMS infrastructure, we have two components. So here these are known as files, and these are your folders. So in your RDBMS infrastructure, let's say these are my folders, and each of these folders will have the associated files. Let's say in e-commerce, we will have the files of orders, the orders data, the customers data, followed by vendors data. So these are my files. So RDBMS follows what is known as the folder file format. Folder file format. Now in the RDBMS term, these folders are known as database, and these files are known as the tables. And this is what are the two initial components of a RDBMS or maybe of a server. So in the server, you will find of multiple databases. So for example, Amazon is having multiple business. So it will create multiple databases, and within each database, it will have multiple files, which are also known as tables. We will talk more about what are the tables, how tables look like, and how they are connected to each other in the next slide. Now we are able to resolve the two major problems. Let me just quickly summarize because you guys must be feeling confused now. So let's quickly summarize everything. We started discussing about what are the problems and what all problems the company would face if they prefer using traditional storage system. The two major problems that we came up with was the same view problem, how to make the same data available to everyone who wanted to query that. The second problem was logical collection and arrangement of the data, how to logically preserve the data so that it is easy to input the data and easy to retrieve the data. We started discussing the solution, and the solution was RDBMS. RDBMS comes with two components, the server and the client, where server is the central storage of the data and client is the software or the GUI that helps the user connect to the server. SQL is a communication language that acts as a bridge between the client requirement and the server. So whatsoever requirement the client is having, he or she will write down that requirement in a form of a SQL query that will be communicated to the server, and the server will process it to return the answer to the client. Now, how we were able to solve the first problem, the same view problem. So the same view problem was resolved by creating server, which was the central data storage, and everyone who wanted to access that data can connect to it. The second problem was resolved by creating these architecture, which is the folder file format. We have database, we have within each database we have multiple tables. But the problem is still not resolved. How the logical arrangement will happen within these tables so that this kind of mesh like a structure is preserved, because you can see that there is a network. The order table is connected to product, product is connected to vendor, and so on. So how this network can be preserved? In order to preserve this, we have to understand the tables. Now let's take an example of a company database. So let's say we have this table. This table is having employee ID, name, joining date, salary, and the last one is the department ID. Now let's say we have multiple data entries or rows. So here this table is named as let's say the employee table, because it consists of all the employee specific information. And then we have the departments table. So here we have the department ID. Here we have the department number. And then let's say we have number of employees. So let's create some data points. Now, before I talk about how these tables are related, let's talk about the terminology associated with these tables. Please remember that these two tables are the part of a database, the company database. So this is my table number 1, which is named as employee table, and this is table number 2, which is my departments table. Now, in this particular table, these columns are known as fields, while these rows are known as records. Now, these are the terms used for the table which is a part of a database. Fields are your columns and records are your rows. If you guys carefully observe, we can find out a common column within these two tables. This particular column, which is department ID, is available over here as well as available over here. Now this is what is known as the relation. This particular common column will act as a relationship between these two tables. So if I ever wanted to connect these two tables to extract the complete information, I can simply use this common column to connect these two tables. Now in the department table, in this particular table, which is departments table, this column has a very special name, or this field is known as the primary field. Now it is known as primary field because in order to input any record in this particular table, I need to declare the department ID. Without having department ID, I cannot enter any record into this table. So a primary field cannot be null, not null, and it needs to be unique. These are the two constraints of a particular column or a field to be a primary field. A particular primary field of one table, so here department ID is the primary field of department table, becomes foreign field. So this is my foreign field. Becomes foreign for the another table. So the definition of foreign field is a particular primary field of one table becomes foreign field for the another table. Now the combination of these two columns, which is a primary field and the foreign field, will establish the relationship. And that's how multiple tables are connected within a database. So if I quickly show you a schema, maybe within a database. So within a database, how multiple tables are connected. Here you can look at a sample schema. So this is known as a schema of a particular database. So here I'm having the customers table, orders table, order item table, and product table. Now here you can see that in the customers table, this ID is the primary key. This particular primary key is connected to this column, which is customer ID. So this is foreign. I'll write F over here. I'll write P over here. Now for orders table, this is the primary key, which is connected to the order item over here. So this is my foreign, and this is the primary key, which is the order item ID. Here again, you can find out the relationship between the product ID. Here it is foreign, and here it is primary. So you can see that all the tables in this particular schema are connected to one another, and we can fetch out the complete information about the detailed information about any product, any customer, any order by connecting all these tables. That is how the data is presented within a database. So this is how RDBMS resolves all the problems that comes if I use traditional storage system. Let's now understand the concept of vendors. Now to understand this concept, we will first of all take a very simple example. So you guys consume coffee, right? So we have coffee. Now coffee as a product, you can find out coffee from the vendor Tata. You can find coffee from the vendor Brew. Then we have Nescafe. Then we have other brands coming into picture. So we have multiple brands and we have multiple vendors. Those who are basically selling the same core product. So the product over here is coffee. The core product is coffee. Now you can consume coffee from any brand which you want. Now what they essentially have done, they have added some flavors, some extra flavors, and they have presented their coffee better from other. So how we decide that we are going to have coffee from Tata, or how we decide we are going to have coffee from Nescafe? It depends on our taste, our convenience, and our choice. The same concept goes with RDBMS technology. Now RDBMS is a technology for which we have multiple vendors. We have Oracle, we have MS SQL, also known as MS SQL Server. Then we have MySQL. Then we have PostgreSQL. Now these are the vendors which are basically running in the market. They are the market leaders when it comes to the RDBMS technology. But how it all started, or maybe who was the first person, I would not say person, who was the first company who developed this technology for professional use, for the commercial use. So let's try to understand the history. Now, history is something which is very important to understand, to be known, because it will give you an idea about how the development was made in technology. It is not a very important interview question, but it is very important for any technology experts or maybe as a data professional that we are aware about how the developments has been made in the technology. So that is very important. Now this person on your screen right now, this person is named as E.F. Cod, and he is the father of the technology RDBMS which we are using today. So in 1970, this person presented a paper named a relational model of data for large shared data banks. Now, when he presented his paper, there was a lot of disruption in the market because at that time, the technology that the market was using was very much bulky. Now, when I say bulky, that basically means it was not scalable, it was not organized. But this person, when he presented his paper in year 1970, the technology, or maybe there was a disruption in the market. Everyone was trying out to implement this technology. Since this person, right at that particular time, was the employee of IBM, he reached out to the managers and the maybe the leading team of IBM. So I'll write M over here to depict managers, and he presented his idea to the managers. So he was basically trying to convince the IBM team so that the IBM team can start working on his idea and can develop a product out of it. Now, what happens, as you guys already know, if a company has to work on a new technology, the company has to put some extra money, and that was the concern of the management. So the management straight away discarded, and the management was not interested in his idea. EF Cod started reaching out the clients of the IBM company. So IBM was basically a company which was serving to multiple clients at that time. And when EF Cod started reaching out to the clients, they got an idea that this is a technology which can help them to basically modify their existing database management system. And they got an idea that this is something that can help them to scale at an exponential pace, because at that time the data was growing at an exponential rate. So there was a lot of pressure that created on top of the IBM management, and that is where in 1974 the company actually started a project named as System R. And one thing which was shocking at that time was this project was not having EF Cod as a team member. So they started this project without EF Cod. But they were actually very late in implementing this technology. By the time IBM was planning about this project, by the time IBM was working on the idea of EF Cod, Oracle came into picture. Since Oracle was already very much fascinated with the idea of EF Cod, they started implementing that project, and they became the very first company in 1979 to make this technology named RDBMS available commercially. Now that is how history started building up. So the idea was developed by a employee of IBM, but IBM, since they were not interested, Oracle took the time, Oracle took the advantage, and they developed the first commercially available RDBMS. Now, how SQL was developed? So we have to go back in this project R. So when the team at IBM was working on this technology project R, and which they were able to develop by the year 1975, they faced a problem. Now previously, if a particular client has to communicate to the server, it was required to write a very heavy code to particularly transfer the request to the server, and that was really difficult to do for a normal person. Let's say if I am a manager and if I am interested in finding out what are the top 10 products which my company is selling. So for me, being a non-technical person, or maybe not a technical advanced person, writing good number of code or a huge code is a difficult task for me. So the team who was working on Project R, they developed a simplified language which they called as SEQUEL. Now that is SQL, but the full form was Structured English Query Language. And this particular SQL is nowadays known as SQL. So that is how this language was developed. Now let's come back and talk about how the vendor development happened. So as I've already told you, Oracle was the first company which came into the market and placed their commercially available product named RDBMS. Now the next, what happened? Now Oracle, when they were working on this technology, they found out that the existing SQL language has some limitations. When we talk about SQL language is designed in such a way that you can use it as a communication language, but you cannot write logics. You cannot use as a programming language. For example, let's say if I have to write a logic using if condition, using for, using, let's say I have to write a function which basically iterates. It is not possible in the base SQL, the general SQL that we all learn and implement nowadays. But since Oracle was working on this particular technology and they were looking for a language which can also implement these kind of procedural tasks, they developed a language that was named as PL/SQL. PL stands for Procedural Structured Query Language. Now the advantage of this language was that you can actually now write your logics, write your conditions, write your for statements, write your loops. You can do a lot of things with this. So here in my screen, I have presented a simple example of how a PL SQL language looks like. So we declare, then we have declared a variable var1 with the data type as number. We begin with the operation. Now variable 1 is valued at 10, so the value which we have provided to the variable 1 is 10, and then we have written a for loop to display the output, which is the multiplication between variable 1 and variable 2. Variable 1 is already 10, variable 2 is from 1 to 10. So in the first iteration I'll get 1 into 10, in second 2 into 10, in third 3 into 10, and so on. Now this is something which you cannot normally do in SQL, but this is possible with PL SQL. So Oracle is a company which developed PL SQL. Let's come back to the vendor thing, and let's first of all summarize everything that we have discussed. So this person, EF Cord, developed the idea of RDBMS system, which was first implemented by Oracle in 1979. SQL was a language which was developed by the IBM team, those who were working in the Project R, and later the name was changed to SQL. Then the Oracle was the company who developed the language PL SQL. When Oracle was already established market player, why other players came into existence? So we already know that we have Oracle, then we have MS SQL, then we have MySQL, then we have PostgreSQL. Now, when Oracle was already there in the market, why other players started coming up in the market? What was the requirement? So the requirement was, the problem with Oracle was that number one, Oracle was costing a lot for the for various clients. So cost of licensing and support was expensive. It was not open source. Second was, since internet was growing at a very rapid pace, Oracle was not compatible with websites. So if I have to connect my website data with the Oracle database, it was difficult to do it. At that particular time, as you guys already know, Microsoft was a player. There were so many technology that was around Microsoft. So we were having Microsoft Visual Studio, we were having Microsoft .NET framework. So since Microsoft was a player, there was a requirement of a technology or maybe a database which is very good compatible with the Microsoft infrastructure. And that is where the second market player came into existence, which was Microsoft SQL Server. Now, when Microsoft launched themselves, the very first advantage was that it was very much compatible with the Microsoft environment, the Microsoft tools. So you can easily run it on your Microsoft Windows laptops and Microsoft Windows desktops. Also, it connects very easily with the Microsoft infrastructure or maybe other platforms that is controlled by Microsoft. But Microsoft also took one opportunity which they found that was a major gap in the industry. At that time, banking industry was facing a lot of challenges because there was transactions that were happening. So since internet was booming, banking industry was also moving towards becoming online. Now, when it comes to online, you have to manage the transactions. So what they found out that there is a lack of having a language which can deal with transactional data. So they introduced a language which they called as TSQL, Transact SQL. And the advantage was Transact SQL was that it was mainly developed to handle the transactional data. Using TSQL, we can still write the procedural logic. Writing loops, writing conditions was still simple, but TSQL was more profound and more, I would say, more easy to handle the transactional data. Now, if we compare here in this particular slide, I have shown you one example of how TSQL block look like. So we begin the transaction. If I go back and show you my PL SQL, it was declare, then begin, simply begin. But here it is begin transaction. And here in the end, you can see that if this condition is true, then we commit, otherwise we roll back. Now, what is the meaning of commit and roll back? So commit means if a complete transaction is done, then we will commit, then we will close it, then we will register that. Otherwise, we will come back. We will come back to the initial point. Let's try to understand this. What is the meaning of complete transaction and what is the meaning of rollback? So let's say we have two person. Here we have person A, and this person is having 1,000 rupees in his account, in his or her account. There is another person, person B, and he or she is having again 1,000 rupees in his or her account. Now let's say this person wants to send 500 rupees to person B. So this person initial image or initial data, I will write image 1 is 1,000. This is before transaction. This person initial image 1 is again 1,000. But when this person is sending 500 rupees to this person image number 2 will become 1,000 minus 500. So 1,000 minus 500, which is 500 now. This is image number 2. And for this person, the image number 2 is 1000 plus 500, which is again 500. Now this particular image 1 is before transaction, so I write BT before transaction. This is also before transaction, and this is after transaction, and this is also after transaction. Now what is the meaning of complete process? When this person will be sending the amount to person B, and if the transaction is completed, then only the commit will happen. So T-SQL language will preserve the data when this complete transaction is done. Otherwise, rollback will happen. Otherwise, it will go back and it will show this 1000, and this person will also get 1000. So the transaction is not completed, so it will come back to image 1. Now in Oracle preserves both image 1 and image 2. So I'm talking about the difference between PL SQL and T SQL. The major difference is that in Oracle, your image 1 and image 2 is both preserved, but in T SQL, once the transaction is completed, then it will preserve the after trigger. So here I have written Oracle uses after and before trigger. So this is before trigger, this is after trigger, this is before trigger, this is after trigger. But T-SQL preserves only after trigger. And the reason it preserves only after trigger is because if the transaction is not completed, let's say due to some network issue, the transaction was not completed, so rollback will happen. And the commit will only happen when the transaction is completed. Now this was the difference between PL SQL and T SQL. Now why next player came into market? Why MySQL? As I already told you that since internet was growing, there was a great need of having a database which is light and which can easily connect with various websites. Now when we talk about Oracle and when we talk about MS SQL, these were heavy database and they require a good amount of infrastructure to basically run them, to deploy them. But there was a great need of a very light database which can connect with any website, and also the particular user who is looking to use this particular database may not have to put that much money, because various startups was also growing at that time. So this MySQL database came into existence, and it was the very first open source database. So it was free of cost to use. And that is where people started adopting MySQL technology, or maybe the SQL technology, the RDBMS technology. So MySQL is a very, I would say it is the first love for any data professional who is trying to learn SQL as a language, because this is open source and this is very lightweight and it is having a very clean interface for anyone to understand. After that, the Postgres SQL came into existence. Now Postgres is also a open source relational database management system, but they solved a very different problem. When they launched themselves, there was a increase in the amount of textual data. So people started messaging. Now, since people were messaging, the companies are required to preserve that data also. And then they need some technology which can help them to perform textual search. So when Postgres SQL came into market, they launched very two unique functionalities. Number one, they gave user with the flexibility to perform full text search. And they came up with a lot of functions which can help you to perform full text search. Whereas they also launched a particular extension which they called as PostGIS. So this was the extension which can help the users to basically interact and analyze the geographical data. Now here we have one example of how we can use PostGIS framework. So let's say we have to find out what all places we have around a particular region. So here we have the latitude and the longitude, and I wanted to find out that what all places we have around this particular place in 10 kilometers or within 10 kilometers. And here you can see the sample code. So select asterisk, and this is the point of a particular place, let's say B. This is my A. Here we are calculating the distance, and then where we have written a condition where the distance is less than 10 kilometers. So you can see that with the introduction of PostgreSQL, these two tasks became very easy for users to perform. So let me just quickly summarize everything about how the development was made. So Oracle was the very first market player which came into existence, and they launched a particular SQL language which they called as PL/SQL. PL/SQL was a language which allowed the user to write down conditions, loops, and write down procedural logic. Then the next market player was MS SQL Server. Now they launched a particular technology known as T-SQL, which was very much simplified to work on transactional data. And then we were having MySQL, which was very lightweight and easy to connect with multiple websites. After that, PostgreSQL came into existence to basically help the user work with textual data and geographical data. That is how development was made. Now, here I wanted to talk about two additional platforms which are not database but they are platforms, SQLite and Google BigQuery. Now, SQLite is a serverless platform. Please remember, it is a serverless. It does not provide you a server. It is a serverless platform which you can download and you do not have to install. You can straight away start working with it. It is very lightweight. It performs very fast. So let's say you are looking to work on pre-development research. You are working on a database where you want to research. You're looking for very quick computation. SQLite platform is a very great alternative when it comes to MySQL or Oracle. It can connect to any server, but it is basically a client, which is very fast and efficient. Google BigQuery, on the other hand, is a cloud-based data warehousing analytical platform, which is available in cloud infrastructure. So you do not have to install anything. You do not have to basically work on managing the server. It is cloud based, so you have to just pay for the services and you can use this particular technology. Now, this is basically a paid thing. If you wanted to work on Google BigQuery, you have to pay. But for a user who are trying to use this technology or maybe a platform for learning purpose, they can use it and they will not be allowed to connect to a server. So they can use the internal server or maybe the internal data which is present in this platform to play with various queries and to learn about it. So we'll be also using this. I'll be demonstrating you how the Google BigQuery looks like and how you can use it for your personal learning. But that was all about this particular video. In this video, as you guys already know, that we have discussed about a detailed theory and detailed history of how RDBMS technology happened and what all came into market and what all improvement were made over the period of time. So we hope now you guys are clear with the difference between various SQL platforms and the history of SQL. Before you end this video, please like this video, share this video with your friends and subscribe to our Scalers YouTube channel.
Okay, so this is your DBMS and SQL bootcamp. So let's start. Let's start with basics of DBMS. So whenever you appear for DBMS interview, the basics thing you should know, like what is DBMS, why we are actually learning this, why it's so, what's the advantages of DBMS, right? So let's first begin with what is even data? Like why is even data important? What do you think is a data? What do you all think is a data? If I would say the efficiency of any company or business, it depends upon the data it has. I mean, user data, data about how people are, how people are interacting. So data is of very important. That information is very important and relevant for any company to take their business decisions to grow. So data is of prime importance and it acts as a core for the company's functionalities. Now the thing is, okay, the data is, we have enormous amount of data, but how can we arrange the data? To arrange data, you need some kind of a system, right? What can be those systems? Yes, data is some raw information, any just piece of information, right? Okay. So how can you arrange the data? To arrange the data, we need some kind of system. One basic system, if I can say, is let's arrange the data in files now. Let's arrange the data in files. Let's say we are developing a data for a university, and I can have something about, let's say, so I can have something about a students table. I can have a students file, students.txt. Then I can have a, let's say for employees, for organization, I have an employees file. So employees.txt file, right? So that's a very fine way to store the data, but that is not the, the good way to or efficient way to store the data. It actually depends upon the type of data you have. So that is where the concept of database management system come into picture. How will you even store the data? What optimization you will do? You just don't need to, store the data, just pour the data. No, you'll have to use the data, right? If you don't manage your, let's say, your wardrobe, you don't manage your wardrobe, you just keep on dumping your clothes like that because you need to store that. But no, you don't need to actually store. You need to fetch the clothes as well. Every day you need to find the clothes. So if you just dump your clothes as it is, so it will be very difficult to you to even find a particular piece of cloth, right? So you need to arrange it in proper shelves. Likewise, there are two important decisions that you need to do. The very first, storing the data. Next is querying over the data, right? Okay. So what is a DBMS? A DBMS is, okay. A DBMS is a software system that allows us to store the data and query over the data along with providing a lot of other functionalities. Okay? A DBMS is a software that allows us to store the data, query the data, along with other functionalities as well. For example, what are the other functionalities DBMS provide us? The advantages of DBMS. First is security constraints, right? Concurrency, how multiple users are accessing the database at the same time, right? There are million of people accessing the same database at the same time. How this is possible? Then backup facility, of course, backup should be there. Then security. DBMS is highly secure. The data is first encrypted, then it's stored. Then maintaining consistency of data, right? Then reducing redundancy, repetitiveness of code. Okay. Now the thing is, okay, we learned what is DBMS, but how can we structure our DBMS? Of course, the very first or traditional way of storing the data is files. But that's not the most efficient way to store the data, right? Can you tell me, okay, let's say all of you, let's write one con of storing the data in file system. Just one con. What do you think? Why do you think storing the data in files is not very efficient? What do you think? Okay. If I store the data in files, if let's say you give your file to somebody, they have the access of the file, they can do any manipulations now. So there is no security, right? So there is no concurrency in files. If one person is accessing the file at one time, no other person is allowed to even access the file, right? No backup facilities or backup you can take. Consistency of data, no consistency at all. Repetitiveness of code, right? So these are some of the cons of file system. That's why we have shifted to DBMS, the database management system. Now, Okay, so you want to store the data. You want to store the data about something, right? Yes, data redundancy cannot be avoided. Yes. Okay. So now the thing is, you want to store the data about something, right? Let's say for an organization, you want to store the data for students, for employees. Yeah. And for each and every student, you are storing something about it, right? So these things are actually known as entities. So what are entities? Entities are nothing but about what or whom are you storing the data for. So for an organization, you are storing the data for students, for employees, for the faculties. Similarly, there are attributes, there are fields. Like what data about entities you are storing. Okay, you are storing the data about student. But for student, you are storing their name, their ID, right? The date they have got the admission. So all this data about entities you are also storing. That is called attributes. Attributes of the entities. Then let's say there are two entities, college entity and student entity. Now you want to store the relationship between them. Okay, student took the admission in college at this date. So this is actually the relation between the two entities, right? There is no there there are separate entities are there. No, there's actually a relationship between entities, right? So the third thing is relationship between different entities, right? So a database that can store the data in the form of entities and it can have some relations between them. They are called relational database management systems, RDBMS. Okay. Another important thing that can be asked, what is RDBMS? Why we are using RDBMS right now? Why it is so prevalent? Why we are not storing the data in traditional file systems? So you will tell all the drawbacks of file systems. What is the definition of RDBMS? What are the advantages of RDBMS over file systems? Okay. Okay. So some of the popular examples can be MySQL, PostgreSQL, right? Now, before going on to the SQL part, let's answer this. Suppose you are given design a schema for scalar. Okay. In scalar, you have their users, you have students, you have batches, right? So you have to design a schema. Now, what do you mean by schema? What do you mean by schema? Schema is the blueprint of your database. Like in your database, what are all the tables you will be having? You will be having a students table, user table, batches table. Like what are all the tables you will be having? And inside the tables, what are all the primary key will be there, foreign keys, unique keys, what are the different keys will be there? How are you arranging the data? So that all the definition of data, the blueprint of data is your schema. Okay. Now, how can you design a schema? That question can be asked. This is just a simple scalar. You can be asked, for example, for a food system, a food delivery system, you want to create a schema for. So for that, you have to design different tables, right? This table it will have a food order table, a customers table, dishes table, items table, right? So you want to create different tables. Then you need to find the primary key, foreign key. So let's see this. So that is how a simple schema design look like. You will have a users table. In this users table, you will have ID, name, their phone number, email. And ID is the primary key. What is the primary key of the table? What is the primary key of a table? Primary key is the unique column, the column that uniquely identifies your table, right? Here ID uniquely identifies your users table. So ID can be the primary key of my table. Unique identification key, yes. Similarly, you have a students table. Then you have batches table. In the students table, you have ID. ID is the primary key. Then you have batch ID. You have name and you have user ID as well. And what is this user ID? This user ID is actually the foreign key, right? And foreign keys, you will mark foreign key like this. This is the foreign key of ID. Okay. Then batches table. In batches table, I have the ID as the primary key, and batch ID is the foreign key of students table. Right? If any other key, let's say email can be unique, right? Every user can have unique email. So you can write unique. That means email is a unique key. Okay. And if you want a complete understanding of primary key, foreign keys, unique keys, so just check out my video. I have made a detailed video of this, and in that I have taken a very good example, and with the example I have explained each and every keys. Okay. Now, so this can be a question, right? See, a definition based question may not be asked. Some real life scenarios can be asked. Just let's design a schema for that. In this, all your theories will be applied. How can you create a table? If you want to, let's say, join the tables, then primary key, foreign key. So all of your theories are covered in this question itself, right? So these type of questions you need to practice. Okay. So if you want to create a table, or let's first understand what is SQL. What is SQL? SQL is structured query language, right? That is the most popular language to query upon the data that I have stored. Now I have stored enough data. Now I want to fetch some data. I want to change some data, manipulate, insert. So all these things I can do with the help of SQL. That is the structured query language. And one more important thing, SQL is case insensitive. Case insensitive means I can write Manpreet like this. Then I can write like this as well. Okay. Both is the same. Okay. It will give the correct answer for this as well, for this. So SQL is case insensitive. Okay. Upper lowercase will not be matter. Okay. Yes. Now, how can you create a table in SQL? The syntax for that is create table. Let's create a table for the students schema. Create table. You have to write the name of table. Then inside the brackets, you will define all the columns, right? So ID column, and you have to write their data type as well. So ID is int, and ID is primary key as well. So you need to write this ID, int, and primary key. Similarly, batch ID, it's also int type. Name, varchar. Varchar means variable character. Name can be of 9 characters, 5 characters. So you have given it varchar. Approx it can go up to 10 characters. Then user ID int. So there's a simple syntax how you can create a table in your SQL. Now, another important query in SQL is select. Select is very important. So what's the syntax of select? Select, you have to give the name of columns which you want to select, means actually read. Read this. So read these columns. From which table? You need to define the table. Where you can write the condition. Then order by. Okay, order the table in this format. So let's say for the students table, I have their ID, their first name, their last name. For this students table, now I need to get the first name of students. Okay, what query can I write? I need to get the first name of all the students from the students table. What query can I write? Help me write the query to get the first name of all the students. Can I write like this? Select. What column I need to select? First name, right? From students. Okay, simple. Now let's say I have another student and its name is also same. Now I want to get unique names only. I want to get A, B and C. I don't want this A again. So what can I write? If I want to get unique names, the keyword for that is distinct. Yes, the keyword for that is distinct. Okay. Now the next important thing to understand here is subqueries. Subqueries or nested query. That is very important. For example, let's say you have a students table. Okay, you have a students table. Now in the students table, you want to give degree to students who are in batch 2022, who pass out in 2022. You want to get the give the degrees to them, but some students will not get degree because they fail. Okay, so we have another table here, fail student. With ID 2, 3 just fail. We don't have to give the degrees to them. So we have a fail table and we have a students table. Now the task is you have to get the students who will get degrees. You will only have to get those students who will get degrees. Okay, that is the query you have to write. How can you do this? Can you somehow get all the students who have failed? Can you get this? Can you somehow get all the students who fail? Yes, I can simply write select ID from fail student. Right? In this, from this query, I'll get all the IDs of the students who fail. Now my task is I want to get the students who will get the degree. So can I write like this? Select ID from students where batch is equal to 2022. But I don't want to give the degree to these students of these IDs, right? This ID, I don't want to give them the degree. So what can I write? Can I write like this? And not in, this is actually the keyword here, not in. Then inside this, you will write this. Select ID from fail students. So what it will do? It will first get the ID of this. It will first get the ID of these fail students. Then it will select all the ID of these students with batch 2022, but who are not there in this, inside this query. So it will return just this row. We can write like this is just to understand how subqueries work. Okay, that is very important for your interviews. You can be asked about nested queries. You are given two tables, then you want to relate something. You don't want this, you want this. So in that case, you can write subqueries. And this is just a keyword. You can write just in, you can write between keyword, exist keyword. So different type of keywords are there. Okay. Okay. Let's move ahead now. Let's understand some SQL clauses. The very first is where. So we all know it allows us to filter some rows based on certain conditions. Let's say I want to get the students who belong to batch 2022. So I can write where batch is equal to something, right? And filter on my rows. Then order by. What do you mean by order actually? Order in real life means you want some arrangement, some kind of arrangement of things, right? In the way you want to. That is the meaning of order. So I said return me the list of return me all the students, but I want order in ID as descending. That means I want to get 3, 2, 1. First 3, then 2, then 1. So you can write here ascending as well, descending as well, whatever column you want to order by, you can give the column name. Okay. Then next important, this is very important. Group by is important for interviews. So group by are mostly related to your aggregate functions. Okay, what are now aggregate functions? Aggregate functions take up some set of values and they return a single value. Okay, they take up some set of values and they return a single value. Can you tell me some of the aggregate functions in SQL? Some of the aggregate functions are, the very first one is sum. Let's say for this column you want to find the sum of. Then you want to find count, the number of something. Then maximum. Let's say there is a students table where we have ID, name and some points. Now I want to get the maximum points. Which student got the maximum point? So I can give max. Then minimum, average. So these are all my aggregate functions. Now, yeah, similarly, you can see this example. I want to get the average of the attendance. So I can give average. Inside this, I can give name of column from students table. You want to get the sum, you can give sum here. Count, you can give count here, right? So these are my different aggregate functions. Now let's say, this is so clear. Now let's say I want to find average attendance of every batch. Now I don't want to get the average attendance of whole table. I want to get average attendance of each batch, every batch. For example, I want to get output like this. For batch 1, average attendance is 70, 80 and 60, average is 70. For batch 2, average is 80. Right? So this I want to return now. So this you see, I don't want to do the aggregate functions in my whole table. I want to group something and then I want to perform the aggregate functions. Right? So the very first thing that I can do is group different rows of the table. I need to group these rows. Then I need to group these rows. And after that, on every group, I need to find the average. Right? This I need to do. So how can I write the query for that? Select what I need to select. I need to select the batch ID and average of the attendance. From students table, group by their batch ID. So first, how this query will work? It will group all the batches and in that group by, it will perform the average function. Okay, so this group by is also very important. Then in group by, you will be having a having clause. If you want to filter after grouping your rows, right? After that, you want, let's say, I want only those attendants who are greater than 80. So from this table, you only want this column. After grouping by, you want this row. So after grouping by, you can use a having clause. Okay. Now let's come on to joins. Joins are again very important. We have, what are joins first? What are joins? What do you mean by joins? In joins, you can be asked like why joins are important, or you are given some kind of tables, you need to join them. Let's say you are given this columns, and you need to perform a query. You need to return that. Let's say this columns are given to you. Now you see, okay, these columns are not present in one table, so you need to join multiple tables, right? So you can perform your joins based on the query you are given. You will perform inner join or outer join. In outer, we have 3 types of join: left, right, and full. Okay. So joins are again very important. They help in merging the 2 tables, right? So this is the syntax. Just you have to write the join keyword and on what condition you are joining. You have to write the condition. Okay. Now let's move ahead. Let's say indexing. Indexing is again very important. You will be asked like why we are actually indexing our table. What's the need to perform or do even indexing? Why we're actually creating index? So we are actually fetching a lot of data, right? We need to fetch the lot of data, right? But what we actually want to do, the idea is we want to get the data as fast as possible, right? We want to get the data as fast as possible. Means the query should run fast. So in that case, we can do indexing, right? So everybody, you have heard about arrays and hash maps, right? Arrays and hash maps, you all know. In arrays, if I say about arrays, if arrays, let's say, not sorted, and now you need to search an element, so it will take linear time. Similarly, in hash map, it will take probabilistic around O of 1, right? So we use indexing. Indexing also reduce our time. It helps to run our query very fast. Okay, if you want to get this query, so you will create index on that. So you can be asked like why we even need indexing. So what you will say, to fasten up our queries. Okay. So indexing is again very important. Then you have to know about the syntax, how you can create an index. So what's the syntax of creating an index? Create, you need to write index keyword, then naming should be like this. You first have to write IDX underscore table name underscore name of the column for which you want to create the index on. Then on which table and which column. Let's again see this with the help of an example. Create index IDX underscore, let's say I want to create an index in students table and marks column. So students table, marks column, on students table, bracket, you will give the name of the column, that is marks. So you need to know about why we are actually creating index. How can we create index? Okay. And when to create index. Can you tell me if can I say when you create table, then just create index? Is this correct? When you create table, then create index. This is actually not correct. Don't create index when you create the table. Create index when you have a query that needs to be speed up. If let's say you are every time you are getting something related to marks, okay, you are every time need something related to marks, this column you every time need in your query. So let's create index on this, right? So create index because of access pattern. Okay, you will see the pattern. Okay, this query is getting this column is getting repeated many times, so then let's create index on this. No, how indexes actually work is it creates a table actually. Inside the memory, it creates a table for every, let's say for this marks column. So 70, 80, 90, for every marks, a separate address is assigned to it. Let's say for address 1, 2, 3. Then how it actually works is, it will say, okay, this 70 marks is actually stored at address 1. So it directly goes into that address and fetch that. Right? So that's something how it speed up your query. Okay. Now how actually indexes work, that you can check out my video. There will be how actually we are creating index. I actually created index on my MySQL. Okay, so you can check that video out. All the videos will get uploaded by 1 week or so. Okay. Okay. Now let's move on to string matching. Like for all the students, I want to get all the students whose name begin with M. So there is a keyword called like. If I want to match a string, a word, so there is a like keyword. Okay, in this like keyword, I have two keywords again, percentage and underscore. Percentage, it matches with any number of characters. Underscore, it matches for a single character. For example, let's solve this question only. I want to get all the students whose name begin with M. So select star from students where name like, name starts with M. So M, after that can have any number of characters, right? So after that, write percentage, right? Now, if you want, let's say I want to find all students whose name begin with any single character after that M. So you will write underscore because it matches for a single character. Just single character after that M. Okay? So this is about like keyword. Now, for normalization, you will be asked like what is normalization, of course. But again, it's not be the case like you will ask, tell me what is 2NF or 1NF, 3NF. You actually will be given a table. A denormalized table is given to you. You can be told, okay, normalize it. Or is it needed to normalize? If you find a need to normalize it, if yes, normalize it. That's something you can be asked about normalization. For duplicate marks, it actually create a list for that. Okay? It will create a list for that. Now, how actually it will be created? I can't cover indexes. If you want a separate live session on indexes, we can do that as well. But of course, you can watch my video. Okay? Index video, you will get to know all about indexes. Okay, perfect. Now, in normalization, you will be asked like, okay, you are given a denormalized table. Let's normalize this. Okay, so you will check, okay, is this following 1NF? Is this following 2NF? Is this following 3NF? Is it violates any of this? You normalize it. So these type of questions you will be asked. Okay, not a direct one. Tell me what is 2NF. Okay. Now, another important thing is asset properties. This is very important. You need to know what is A, C, I, D. A stands for atomicity. C stands for consistency. I stands for isolation. D stands for durability. What are all this? Atomicity means either everything should happen or nothing should happen at all. Consistency, as the name suggests, your database should be in consistent state. The system should be consistent before the transaction starts, as well as it should be consistent after the transaction ends. Similarly, isolation. It's also suggesting us something. Okay, there are multiple transactions that are happening, right? But other transactions running in the system should not affect a given transaction. All the transactions should be isolated from each other. They should not hinder their output, right? Now, durability. Durability says after a transaction is ended, its result should persist. This is not be the case like if there's a hardware failure is there and your result is just gone. No. If the transaction is ended, your results should persist. It should be there. Now, how transactions actually handle concurrency and ensure the asset properties, it's there with the help of transaction for isolation levels. Okay, so do check out the transaction video as well and transaction isolation levels as well. Read uncommitted, read committed, repeatable, read serializable. Okay, so you will in our video we're actually doing this like in SQL. What happened if your isolation level is this? What happened if your isolation level is this? Okay, so that will be very interesting video. Do check that out as well. Okay, so what I want to tell you in this session is key exact questions are not be asked. Give me the definition of this, give the definition of this, right? So you'll be asked some by twisting and turning the things, right? Like in normalization, you are given a table, just normalize it. So these type of questions can be asked. Some real life scenarios type of questions can be asked. Okay, so you will have to prepare likewise. About views. Okay, what do you mean by views? Okay, if I say views are kind of an abstraction. They are kind of an abstraction over real tables. They will provide a visibility to data that you want to provide. They act like a table, but there is no data stored in them. For example, let's say you are in an organization and you have prepared a table for, you have prepared two tables. Okay. some tables, let's say some students, some employees, something. Now, another department, someone come to you and they want the complete information about both the tables. Now, you don't actually want to give them the access of the tables, right? They can manipulate your tables. They can change the rows. So what you can do is you can actually create a view over them, and you give them the view. So they are the kind of abstraction. They're actually not the real table. Now they can't change or manipulate your real tables. But then also they have the complete information, right? They can use it, they can query over your views as well. Okay. And how can you create a view? What's the syntax of view? Create. You have to write the view keyword, then name of the view. Let's say I want to create a view on students and employees. So is students, comma, employee. Then as you want to give, you have to write all the query. Just this syntax. It will create view on whatever query you will write, it will create view on that. Yes, a kind of a virtual table. Kind of an abstraction over your table. It's not a real table. It's kind of an abstraction over your real table. Okay, if you don't want to give your tables, complete tables, then you can create a view on that. Right? Or let's say you always want to, want something from this both the tables, students table as well as employees table. So every time you are performing joins, so what you have done, you have created a view over that, so that you can now perform all your queries in that views. You don't need to join students and employees first, then you can perform your query. Okay, your view is created and you can directly perform all your queries in that views. Communication is not that great. Can you give few tips also how to prepare for SQL DBMS especially? Okay. So communication skills, you don't need to actually work on your communication skills. What you can do is you can remember, you can learn this, like let's say for views. So what you can do is you actually learn what is view, how can we create views. So just try to explain someone or try to explain yourself how you will explain to someone. Okay, take something pen and paper and try to explain. If someone wants to learn views, how can you explain views to them? So first you will tell them the definition, then you will take an example, then you will take some real life scenarios so that they can connect well, right? So then slowly and slowly you can able to improve your communication skill with respect to DBMS and SQL as well. Directly if you work on communication skills, so it will take time. Okay, so but this can improve your communication as well as your subject as well. Which are subjects we need to prepare for service based companies? Subject service based companies, to prepare well, first you need to do DSA. DSA is very important. Then your resume should stand out. You should have a good LinkedIn profile. Then you should have basic knowledge of development as well. So all this we have already covered. You can watch our video on this resume, LinkedIn, DSA. Then you can watch our JavaScript videos. And you can have, we have some basic front-end projects also. You can take up that. Then little bit of CS knowledge is necessary. DBMS, OS, CN. Okay, when I'm facing technical interview, I know the concepts and queries, but I get nervous and forget what should I say. Okay, this will happen, but the fear will get away if you practice more. So try to do some mock interviews. Before actually getting on to the actual interview, try to do some mock interviews. This will help. And of course, the trick you can also apply. Try explaining to yourself. If you want to explain joints to someone, how can you do this? Then your nervousness or your thing will get solved. And try mock interviews. It's very important.
Hello everyone, welcome back to Scalar Academy YouTube channel. Myself Vamsi. In this particular tutorial, we will be looking into the another article from the interview bit. Okay, what is this article all about? So often I used to get a lot of questions from my juniors regarding the product-based company interviews. Not even product-based companies interviews. It's about every company interviews. Okay, so the question was, apart from coding, what are the other areas they will be asking questions from? So I used to say DBMS, OS, and computer networks. So yes, so these are the very important things. So that will be focused in an interview apart from coding as well. So in this particular tutorial, we will be learning one such topic like subject named database management system. So what is database management system and what kind of questions that you can expect in an interview? Okay, so now in the next 1 hour, 1.5 hour, what are we going to cover? So we will be starting right from the what is it data, and then database, then DBMS, and how the data has been stored in a different manners, and where that database has been placed, and how to interact with the database, and how to access the database data from the databases, and what are the ways to access the data, and how to store such a huge data in one singular database. Will it be over, like we will be discussing all the pros and cons of storing data in the database, and what are the other alternatives that are being we will be having. And also we will be learning about normalization, two-tier architecture of a database, three-tier architecture of a database, and what are different types of database structures. Okay, like so it will be easy to code and it will be easy to represent, like store, but how to communicate with others? Okay, how to, like, it's not like, oh okay, tell me about how did you store your data in this particular database. It's easy to show your database like code. So this is how I have written the code, and this is how I will be storing my data. So here comes the picture called entity relationship diagram. Okay, so that is the actual thing. So we'll be asked in a system designing rounds. Okay, if your interviewer is focusing more on to the low level designing. Okay, so I highly recommend you guys to watch this video till the end. Okay, so that you will get a bigger picture and better picture on what we are going to do in next 2 hours, and how to answer such a questions if you are in an interview. So before moving on to the actual video, I highly recommend you guys to please do subscribe to this channel. Please hit that like button up, and please let us know in the comment section how did you feel about this particular video. So let's discuss the very first question. So the question stated was, what is mean by DBMS and what is its utility? Explain RDBMS with examples. So they are asking us, so define what is DBMS and what is its necessity, like what is the need of DBMS and RDBMS. So RDBMS is one type of DBMS. Okay, and they are asking us what is a DBMS, RDBMS, and explain it with some example. Okay, so let's try to understand what is DBMS first. DBMS. So let's try to decode this whole word. Okay, so a database management system. Okay, and again we'll talk about this first. So even in this we'll talk about this data. So what is a data? What is a data? So can I say that a raw input which is needed in the future, with that aim we will be preserving that. Okay, like what I'm trying to say was, so the data is something which you felt, okay, which is a very needed one. It might helpful in our future, so that if you felt that is needed and helpful in the future, then you must need to store that, right? Preserve that data. So then it is called as a data. Now what is a database? Now it's a, you can say that, a group of interrelated data. What is this interrelated data? So let's say um, we are in a college. In college there will be around 5,000 to 10,000 students, right? 5,000 to 10,000 students. Now I need to keep them, like I need to keep all the students data forever, like at least for next 4 years. If I joined in my first year, I need to preserve that data for the next 4 years. So what will college do? So they will store all the details of CSC people in some place, in some table, let's say, like in some place. Just assume that it's a block, okay? CSC, and then ECE, then EEE, and even they do all this storing in some other folder. Let's say 2017 to 2021. So 2017 to 2021 is a, you can consider as a folder, and again in that folder we will be having other folders like CSC, ECE, EEE, and in that CSC folder we will be storing our data. So here all the CSC data has been stored somewhere. So can I say that this is an related data? So that is called a database. So this entire thing now is called as a database. Done. Now we'll move to the next thing called management system. So basically let's say I have stored all the data of first year students. Now after moving them to the second year, so I need to update the courses which they have enrolled, or let's say a few students left the college, okay, few students left the college, so I need to update the DB, or I need to update my so delete few students, or so there were some people who joins in the second year, right? So I need to insert the students. So can I say that all these were few operations that I need to perform on database? So just imagine, okay, just imagine like you will be having some kind of interface, okay, you will be having some kind of interface, and you will be having your database here. This is your database, and this is your interface, which helps you to perform all these kind of operations easily, okay? Then this is called as a management system, and with the combination of this mission is called as a DBMS. Now you got the what is DBMS, right? So database management system. So you will be having database, okay, and also you will be provided one interface, which is we are calling here it as a language, so that you can easily update your tons of data in a single go. Either it can be delete, insert, update kind of stuff, okay? So that is what DBMS means for. So now I guess we have answered the very first question. Now explain RDBMS with example. Now what is this RDBMS? So we know what is DBMS. So in DBMS we have different types, like types in the sense how we are storing our data, that's it. Okay, so one of the way is RDBMS, so which is called as a relational database management system. So a relational means storing the data in the form of tables. So what does it mean by tables? So let's say I have this kind of one table. So generally for every table we will be having some rows and columns, right? Rows and columns. So all these were rows, row 1, row 2, and these are all columns, column 1, column 2, column 3, column 4, column 5. Now what does this column states for? So the column states attributes or properties, and columns are like rows are the data which we wanted to store, So let's take one example and then I will try to explain it with you. So earlier we have talked about college data, right? So now let's say we are storing some student details. So if I wanted to store the student details, what are all the details which I am going to store? So can I say that I have to store the student ID, which in terms called as a roll number, and I need to store the name, mail ID, and branch, and like CGPA, so etc., mobile number. So these are all the common properties of every student. Okay, common properties. So these are called as attributes as well. Attributes. Okay, attributes. Now what is a row? So row means each student data, each student data. Okay, we'll draw one table here. So we'll be taking only few columns. So roll number, name, and a branch. Okay, now this is our table. Yeah, this is our table. Now I will be storing the very first student. Let's say roll number is 100, name is XYZ, branch is CSC. Now again I need to store another student, which is roll number is 101, name is ABC, branch is ECE. Then goes on. Okay, so this is, can I say that this is called as a one student data, student one data. This is called another student. So all these were rows, and also these can be called as a tuples as well. Tuples. So these were columns or referred as attributes. So this is what, if we store our data in this particular format, this is called as an RDBMS. Okay, relational DB. So this is called relational DB, and RDBMS means it's a language. So it provides an interface called, it might be MySQL, SQL, MS SQL. Okay, so yeah, these are all the very famous RDBMS languages. Now you can use any of these things and you can interact with the DB. You can perform some operations on the DB, whatever you want. Okay, so there were some commands, so known as SQL commands, MySQL commands. So by using that you can interact with your DB. Okay, so we'll talk about those things as well in the later part. Now that is what we have seen for this thing, this particular example. Okay, so they have taken one website. Okay, they have taken one website. So yeah, so here there is a website front end, and you just assume you have requested some data. Okay, like you have an interface like this. Look, where you will be giving the student roll number like 100 or 200 something, then submitting. Okay, so after submitting, you will be getting all the student all the details of that particular student who is bearing that roll number. Okay, now how it should go? So you have a website, then it will make a call to the DB, which is an fetch. Okay, fetch data, then it will go to the database. So here you can find the student record. Okay, so that is been returning here, then it will return here. Okay, this is how the flow, the control should go here. Okay, I hope you got some enough idea on what is what is data, what is database, what is DBMS, what is RDBMS, and how does it work. Okay, and what kind of data we store there and how we store there. Okay, now the second question is, what is mean by database? I guess we have answered this question earlier, so let's go try to walk through this definition. That's it. So a database is an organized, consistent and logical collection of data that can be easily updated, accessed, manageable. Okay, so earlier we have discussed a formal, like informal definition. Now you can see the formal definition. So if you are in an interview, you should something first tell something like this. Okay, then you can pick up one example, then you can explain it in a better way. Okay, so if you are in an interview, your interviewer expects you to tell the concept rather than a formal definition, but don't directly jump into the a real world example as well, because it won't show your communication skills. Okay, so first tell this. Okay, then explain it with an real world example. Database mostly contains a set of tables or objects. Okay, so that is what it is showing, like whatever we have discussed. So they have taken RDBMS here. Okay, that's why they are representing as a table. Okay, so just go through that, you will get it. Now the next question, mention the issues with traditional file-based systems that make DBMS a better choice. Okay, so they are asking us actually why we need databases. Okay, why we need databases? We have file systems, right? Like we are storing all our data here. Then what is a need? So the need was they are given 3 examples. I think that should be sufficient if you are in an interview. Okay, now the very first thing is searching. They are referring it as indexing as well. So searching means what does this searching? So let's assume you are in a file system environment, like where you are storing all the details in your computer manually, like folders. Now I wanted to search for one particular student whose roll number is 201, right? 2001. Now imagine, okay, there were 10,000 students in a college. 10,000 students in a college, and you need to search the student roll number where it is being referred as in 2001. Now how much time it will take, how much effort you need to put here. So in worst case, if that 2001 is being stored in the very last, okay, then you need to cross check 1000 files. Okay, is this what I'm looking? So if it eventually makes your job little hectic and complex, right? So that is the one of the major issue with the file system. So this issue has been overridden by the DBMSs. Okay, so they will be providing an interface, okay, like language. Then you can simply write a query, okay, like give me the 2001 ID student. Then it will give you. That's it. It's as simple as that. Okay, so all you need to know is just one query. That's it. Okay, it will get your job done in within fraction of seconds. Okay, so you might be thinking 10K is reasonable search, but nowadays people are searching it, like the data has been gone to PBs, okay, like 100 TBs. Okay, it's up to your imagination. Okay, now what you can think of in a bigger way. Now the second solution that we were considering is concurrency control. So if you don't know what is concurrency control, it's okay, but as of now I will be stating this in a very simpler manner. So let's say you can consider it as a multitasking. Okay, so lack of concurrency control, which leads to one operation locking the entire page. So they are simply stating that, let's say if you are searching for a 2001 student, okay, then you are blocked by this particular activity only. You are not able to do other activities, like you need to delete some student details. Okay, delete student details. Now what you need to do, first you need to complete this, then you need to come back to this, right? Which is like, if this particular task is taking 30 minutes, then you, to complete this particular task, you need to wait for 30 minutes, right? So this is one of the major problem in file system. It is overcoming by DBMS. Okay, so where DBMS supports concurrency control, where you can do a multiple task at a time. Now integrity check, data isolation, atomicity, security, etc. So these are some of the advantages over the file-based systems in DBMSs. Okay, so let's move on to the fourth question, which is an explain a few advantages of DBMS. I think like we have covered two advantages in the earlier question only, but yeah. So yeah, these are all the few advantages. We'll talk about each of them in detail. First one is data sharing. We'll talk about a scenario a 100 years back, sorry, a 40 to 50 years back. Okay, let's say earlier they used to store all the details in one mainframe system. Okay, mainframe system. So where there is nothing called a DBMS earlier. Now they have this. So this is their system, and they have stored all the data here. Now this is employee 1 and this is employee 2. Now employee 2 needs the data. Employee 2 needs this particular data. Now what happens? You need to copy these things. You know that it won't happen, because either he has to go and use this particular system. That's it. That is the only possible way there. So which is not possible, right? Every employee needs an own problem, like one work. So what is a kind of problem that way? So they decided to terminate this particular problem. So how did? So just imagine the case where this data has been in some central storage. Okay, central storage, one room kind of stuff. Now all the systems were being linked to this. Okay, all the systems were being linked to this. Now everyone, like every employee, can access the data with some credentials. Okay, that's it. That's as simple as that. So this is one of the biggest advantage here. So you will be storing all your data in this database, like cloud or something. Okay, you will be putting it somewhere. and you will be giving connections to the all the employees, they can access it, right? So you can imagine like whatever the data you are using nowadays, like whatever the app, whatever the website, whatever the YouTube video, okay? So do you store all the YouTube videos in your mobile? No, it is coming from somewhere, okay? They are storing it in some big data centers, and we are getting that. That's it, okay? And integrity constraints. So the existence of such constraints allows storing of data in an organized and refined manner. So basically these integrity constraints helps us to access the data uniquely, okay? And which helps to reduce some problems like anomalies, okay? We'll talk about them later. Now third one, controlling redundancy in the databases. So redundancy means a duplicates. What is this duplicate stands for? Let's say like file based scenarios. So you will be storing all the students details. Unfortunately, you yeah, you like just imagine, okay, you are copy pasting everything, okay? So you have copied and pasted for the multiple times. So now all your files, so for each student, let's say 2001, it will be storing 3 copies of it, and 2002 3 copies. So now just imagine if you have 1000 students, then each student copy is been storing for the 3 times, then it could have been gone to 3000 copies. Now you are wasting a lot of storage here, right? And it will make your system little slow on accessing and searching as well. So to overcome these problems, our databases usually don't allow redundancy, okay? It will try to reduce the redundancy as much as possible, okay? So it will store only the unique values, so it will help you to search it easily, and it will provide an way so that you can maximize your utilization of databases. Now data independence. So here let's say now in this case we'll take this particular file system example. So you have identified that, okay, for every student you will be having 2 copies, okay? For every student you will be having 2 copies, or you will be storing the things in 2 folders, okay? 2001. Now you wish to delete one file, okay? You wish to delete the student record. Now you will go to this folder and you will delete this, okay? Now you thought this is the only folder where I am storing all the data. You forgot about these 2, but after few years you find that I haven't deleted the data here, and which leads to the complexness, right? So to overcome that kind of problems, okay, so your DBMS provides an way to, okay, so to link all the data, and if you delete somewhere, okay, if you delete that particular ID or file in some table, it will delete all the existing or the same files in some tables as well, okay? So that you can use the things in an efficient manner. Now provides backup and recovery facility. So yeah, so like just imagine, okay, you have stored all the data in some folder, and you mistakenly deleted that particular folder. Now what happens? You can't retrieve that data now. So with that thing, DBMS provide a way to back up your files, and you can recover them like even after deleting them as well, okay, by mistakenly. And data security. So usually Okay, nowadays we will be having lot of security like passwords, file folder passwords, file passwords and all, but back then that was not the scenario. And just imagine you will be saving all your bank details in one folder, and if I go and if I open that folder, then I can able to access all your bank details. Now what is it? What happens? Bankrupt, right? So to overcome that kind of problems, DBMS has provided better security for your data. Okay, you can give personalized authentication, and you can keep track of whoever are using login using that particular authentication. Okay, so this is the advantages of DBMS. Okay, so let's see the next question. So explain different languages present in the DBMS. So following are various languages present in the DBMS. So languages in the sense like to interact with your DB. Okay, so here languages were some commands. Okay, commands. So in that language we will be having 4 types. Okay, first one is DDL, data definition language, so which helps us to create a tables, create a DB. Okay, so it contains commands which are required to define the database. Okay, like create, so it will help us to either create tables or database. Okay, we have seen what is table, what is database, right? And we have alter, which helps us to alter the things, or okay, alter the things present in the either in the table, like table names, okay, column names, sizes and type, like that. And drop, a drop is used to drop the data present in the tables, and truncate as well. Okay, so there is a small difference between drop and truncate. We'll talk about them in later part. So rename, so rename is helps us to rename the tables and database names. Now the second one is data manipulation language. So it contains commands which are required to manipulate the data present inside the database. Okay, like we will be having a data, okay, and then we will be manipulating it, means either we are updating and we are inserting and we are deleting, and these are all the commands which are there for DML command. Okay, DML language. So select is used to retrieve the data. Okay, retrieve the data. And update is used to update the data present in the table, and insert is used to insert the data into the database or table, and delete is used to delete the tables, okay, or data. Now the third one is DCL, so data control language. It contains commands which are required to deal with the user permissions and controls of a database system. So basically we have talked earlier, so a database provides a better data security. So how does it work? So let's say we have a person, okay, and we want to, like, there is some table, okay, student table or student database. Okay, and there are 2 people for in college, let's say principal or students. Okay, now what I need to do, I need not to allow the, okay, I need not to allow the access permission to the students, right? Because students are not able, like cannot access this student table, so only principal and support staff should be able to access this particular student database. Now just imagine another case, okay, where students are working in some project, okay, and they need some database access, so that we can access some database, like we can grant the permissions, and after some time, like whenever their work is done, we can revoke the permissions. So to grant and revoke, we will be using data control language commands. Okay, data control language commands. Now the last one, transaction control languages. So here transactions means like you will be performing a lot of sequence of operations, right? Be it update, be it delete, be it inserting, okay? And we will be keeping track of all these things, okay, like whatever we have done so far. Okay, now we need to save them up. Okay, here commit means like whatever transactions you have made, be it inserting, update, you need to store them. Okay, you need to store them before you are leaving. That is what commit means. And rollback means, let's say you have unfortunately deleted few tables. Now you need to get back those things, so then you can use rollback. So save points helps us to save at the current point. Okay, and these are all the different languages provided by the DBMS to interact with your databases. Okay, now the next question was, what is mean by ACID properties? So very important question. Okay, very important question. So it's a crime if you are not prepared ACID properties, and if you are attempting any product based company, so you are for sure you are going to screw up your interview, I guess. Okay, so what is mean by ACID properties in DBMS? So ACID stands for, like ACID stands for atomicity, consistency, isolation, and durability. So we'll talk about them each. Okay, each one. Now in simpler manner, they are saying that atomicity means all the changes to the data must be performed successfully or not at all. So we'll take one phone pay transaction or anything. So nowadays everyone using phone pay and all, right? So just imagine you started one payment. Okay, you started one payment to the one shopkeeper. Okay, started one payment to the shopkeeper. So now what is your aim? Either it has to go to the shopkeeper successfully, or it should not go. Okay, it should not debited amount and not credited. So in either of the cases you don't have any problem, right? This is what an user wants. It's not like, so my amount got detected from my bank. Okay, amount got detected from my bank and it is not credited into the shopkeeper account, then there is a problem. So a DBMS states that make sure that either of the things, okay, either it should be success and it should not happen at all. So this is the principle that it follows. Okay, it should not go, it should not start and it should not end in the middle. Okay, so that is what atomicity means. Okay, so if you have started, you need to finish that. Okay, there is no midway coming back. That is what it is saying that. And second one is consistency. So consistency means whatever the data, okay, like so this property ensures that the data remains consistent before and after a transaction. So you will be like, you will, let's say, so in a earlier example, so your current balance was 2000. Okay, and you have started a payment of 1000 rupees to the shopkeeper, now after, okay, now just imagine the scenario as this is a success status. Okay, means your payment got successfully completed. So if you open the current balance now after payment, then it should reflect 1000 here, and in shopkeeper account it should be like balance plus 1000, right? If in any of the cases, for any of the reasons, if it fails to update like this, okay, then we can say that this is an inconsistency data. Okay, so if it is something like this only, then we can say that it consistency. So whatever the data happened, like transaction happened, it has stored all the data over there, so we are good now. Okay, so the second principle must be, so after performing any operations, the data has to be keep on updating. That's it. It must be stored all the updated data only. Now the third one is isolation. So what is this isolation means? So you might be performing different or multiple transactions on the same side. Let's say so there is a shopkeeper and customer 1, customer 2 and customer 3. So everyone is doing phone pay transaction only. Okay, so you are sending 100 rupees and this customer 2 sending 50 rupees, customer 3 sending 200 rupees. So here if you are doing your transaction, you can't say stop it, like okay, hey customer 2, so sorry to interrupt, please be away, so let me complete my transaction. No, you should not tell like that. Okay, so whoever transferring amount to the shopkeeper, you should respect them and you should make sure that everything goes well. Okay, so it's support, like this is how it works in the RDBMS. Okay, so irrespective of any number of people are doing the same operations at the same time, okay, the data has to be stored or preserved all the time, and there should be no interruption occur to the other customers who are sharing at the same time. Okay, so that is another principle or property of a DBMS. And the next one is durability. What is durability? So here let's say like in your current balance is 1000 rupees. Okay, and all of a sudden your mobile got switched off. Okay, switched off. Now again you put some charging and you opened again. Okay, open your mobile again, and you have seen that there is a 900 balance in your account. So this should not be the case. So every time, like after every transaction, you need to like keep track of whatever happened so far. Okay, and everything has to be preserved for forever in the future. So here our data is like, so just imagine, okay, you have sent 200 rupees to someone, 200 rupees to someone, and still after 1000, okay, so your correct from the 1000 you have sent 200 to someone. So now your database should reflect 800. Instead of this 800, if it is still showing 1000 rupees, then it is failing, right? So anyhow, like we are getting benefited, but this is failing, right? In case of missionaries. So that should not be the case. So the same state should reflect everywhere. So if you checked it in a phone pay, if you checked it in Google Pay, so all the same amount has to be shown. Okay, so in phone pay it is showing 800, in GPay it is showing 1000 rupees. If I go to bank passbook, it is showing 500 rupees. That should not be the case. Okay, after every transaction, either it has been failed or passed, it should save the previous state, and if it is successful, it should show the current state. Okay, in all the possible ways that he or she can store. Okay, in case of different applications that nowadays we are using. Okay, that is what this durability means. Okay, now these ACID properties make sure that every transaction, like whatever operations you are performing, or everything are going pretty good. Okay, nothing is happening in between, and these are all the principles that every DBMS should follow and will follow as well. Okay, now let's move on to the next question. So the next question is, are null values in database the same as that blank space or zero? Good question. Good question. Like personally, as a software developer, I see a lot of null values in the lot of databases. Okay, after seeing them, like if you feel that this is not the case, so I can't handle this and what all these null values, so uh, then you might be in some wrong thing. Okay, you should be wondering how we need to handle that. Okay, what if there is no data but I need to put it on the UI part? Okay, so then you need to understand the context over there, like what kind of scenario that you are considering. So just imagine, okay, just imagine you just imagine as a phone pay only, phone pay, and you need to print all the current balance. So if your current balance is null as of now, okay, null, so which means no data at all, no data. So which it doesn't mean that, it doesn't mean that 0 rupee in your current balance, right? So just imagine like where in your from to your database you have a null value, okay, and at the same time user has asked for current balance. Now since you have assumed that null balance as a 0, if you assume null balance as a 0 and for user you have shown 0 rupees in your current account, now user will straight away ping the client services like customer support, because in current balance he is thinking that he might have 25k, but you are showing 0 as current balance. Okay, so 0 means 0, null means not 0. Okay, null or blank space, whatever here. Okay, this is probably the very good example. I have personally faced seen this problem many times as a fintech company developer. So no, a null value is a very different from that of 0 or blank space as it represents as a value. Okay, so they are saying that null, no, null value is null value, 0 is something 0 only. Okay, so they have given one example here as well, but yeah, so whatever I have discussed from my experience is also good. So null values in number of courses taken by a student represents that its value is unknown, whereas 0 means in it means that student hasn't taken any courses. So here they have considering a scenario like table where they will be storing number of courses a student has been enrolled. Okay, so like just imagine you have a UI and you will be providing the roll number, and you will be having button like submit, and after submitting this after clicking on this particular button you will be getting all the course details where student has been enrolled, right, where student has been enrolled. Now if you got all the null values, like all the null like empty values, it doesn't mean that student hasn't enrolled in any courses. Okay, it means only that you will be like data is not available only. Okay, it doesn't mean that student does not enroll in any courses. If and only if you get 0, it means that student does not enter enrolled in any courses. Okay, null not equal to 0, blank space not equal to 0. Okay, let's see another question. So question number 8, what is meant by data warehousing? So the process of collecting, extracting, transforming and loading data from multiple sources and storing them into one database is known as a data warehouse. So they are saying that we will be getting data from the different sources. Okay, and from that different sources we are extracting the data what we wanted. Okay, and like let's say there is this YouTube, right? YouTube. So in YouTube everyone gets the uh, like customized ads, right? Customized ads or some advertisements, okay, posts and all. So you can mostly have related to that, like so if I went to Amazon, okay, if I go to Amazon and if I search for any TVs, okay, if I search for any TVs or laptops, and then if I go to YouTube I will get advertisements or in between ads which are related to the either laptops or TVs. And even if I did the same in Google search, if I go and search for few MacBook prices, MacBook Air price, MacBook Pro prices, then if I come back to YouTube, again I can see the ads of YouTube with the prices tag. Now how this is working? So here the sources are very different, right? So here we are getting the data from apps, here we are getting the data from internet browsers, but we are using that particular, like we are combining all the data together and we are just searching the things, right? So this is what a data warehousing means. Okay, like you will be getting data from the different sources and storing in one place and processing it together, and again you will be using that same data for different purposes, not only for one purpose. Let's say like I got the data like Amazon data and Google search history, and I'm storing them in one place. Okay, I'm storing them in one place. Now this is being used for YouTube, and also in for Amazon also, like it will try to show all the things what I have searched previously on my screen only, right? For apps itself and for Google and for Play Store. Okay, if I go to Play Store and if I search for any shopping app, then I will get all the shopping apps, right? All the like Flipkart, Amazon, Meesho, all the things. So how this is being happening? So you are getting data from different sources, and from that different sources you are processing it together, and they felt that you are looking for one MacBook Pro, and then they are keeping on advertising that MacBook Pro everywhere you go. Okay, if you go to YouTube you will see that, if you go to Google you will see that, if you go to Amazon website you will see that. Okay, so this is how a data warehousing works. Okay, let's move on to the next question. So explain different levels of data abstraction in a DBMS. Okay, so here what is a data abstraction first? So if you don't know what is data abstraction, so a data abstraction means, in simpler, in OOPS terminology, hiding the unnecessary complexity and showing only unnecessary parts. Okay, the best example would be the ATM. Okay, like we only care about like putting the card and entering the password and getting the money, but we really don't know how that is being processed in the backend, and how your request, like how your APN pin is getting validated and how your barcode is being scanning and all. We don't care about that. We only want money. We are getting that. That's it. Okay, this is what abstraction means. So they are asking us what is happening behind this particular data and what are the levels are there in the database transactions. Okay, so here I would like to point out, divide this whole part, okay, into the three parts. Okay, let's say this is part 1, part 2 and part 3. So 1, 2, 3. So just imagine, you can assume this part 3 as an like UI where a user can access the data. Okay, like you can simply consider this as one website. Okay, consider this as a one website, and now what all you can do, so you can request the, like you can submit your roll number and you can get the results, right? That's it. Now that is what happens at the user screen. Okay, and then in the second level this is for a developers. Okay, this is for a developers. Okay, this is for developers who are developing your website. Okay, so where they can directly interact with the DBs, okay, by using some commands. They can manipulate the data, they can retrieve the data, they can update the data. Okay, so this is what a developers can do at the level 2. Okay, level 2. And now this level 3 people, like where users cannot access this level 2 permissions. Okay, so level 3 is only like level 3 people can only access the level 3 thing, but level 2 people can access both level 3 and level 2. Okay, and there here comes the last level, which is a level 1. So in this particular level we will be providing only the details of how much data has been stored, okay, and how much memory has been used and who are all using that. It will be for organizing heads. Okay, organizing heads. Okay, like all the databases are being created. Okay, database creation and all. So here this is for developers and this is for clients, okay, who are using your end product. Now if you wanted to put it in a hierarchy, so this level people, level 1 people can access all the 3 levels, but level 3 people can access, level 2 people can access only 2 levels, first 2 levels, and level 1 people, level 3 people can access only level 1. Okay, so these are all the levels or abstraction layers available in the DBMS. Now they have named these levels as well. So this particular level 3 is called as a view level, where it can be accessed to the clients. Now level 2 is called as a logical level, where logical implementation and actual data storing happens. And level 1, where actual it is called as a physical layer. Okay, physical level or layer, whatever you call it as a. And this is where actual databases are being stored, and there will be some configuration details as well, which is not occurred for developers and users. So this is the abstraction that it is following, and these are all the levels of abstraction. Okay, and layers as well. So this is about this question. Let's move on to the next question. What is mean by entity relationship? Explain the terms called entity, entity type, and entity set in a DBMS. So it is in 2 questions, okay, and 4 definitions. Okay, so what is the first question is, what is ER model? So ER stands for entity relationship, entity relationship model. So we are, okay, like, so we are storing a lot of like we are having databases. In that particular databases we will be storing all our tables, and we will be linking, like we will be having some relationship between a few tables as well. So how we are going to represent them? So just like as a developers we can remember them, okay, but to understand, like to put it in a high level context, we need to represent them as a diagrams. So that particular diagram is called as a ER diagram. So if you can observe here, you can see, right? So we will be having a 2 entities. Okay, this student is one entity, college is one entity. And what is an entity? An entity is a real world object which has some existence. Okay, so student is one object, like entity, college is one entity. And what is the relationship between among these 2 tables? So entity is an table. Okay, so studying, so student studying in college, right? So there is some relationship. So every student will have a college, right? And in college students were there, obviously. So this is called as an entity. So entity is an table. So for every table we will be having an attributes. So attributes are also columns. So entity means referring to the only one particular object. Okay, a student, like only one person. Okay, an employee, one person. That's it. An entity type means grouping like similar kind of things, okay, onto the one thing. Let's say you can see, right? So every student, okay, here, so every student will be having the same attributes like student id, student name, student email id, mobile id. So every student will have the same kind of attributes. Then we can call them as entity type. Okay, an entity type is defined as a collection of entities that has the same attributes. Okay, so if I consider different students, so student 1 will have all this student id, name and all, and student 2 will also have the same name, college and all, and student 3 will also have the same. So after seeing these 3 students, I can say that id, name and branch is common for every student. Now I can refer them as a one like entity type. So these are student types. Okay, so it is something like data type in our programming language. Now the next question is entity set. Entity set. So an entity set can be defined as a set of all entities present in a specific entity type in database. For example, set of all students, employees, teachers, etc. So now whatever, like whoever having the same set of entity types, like here student 1, student 2, student 3 will have same entity types, right? Now I can group them all, and after grouping them all, I can say that these are all the students. Okay, whoever having this roll number, name, whoever belongs to this particular college, I can say that all of them as a students. And whoever having employee id, employee name, and so works in some organization, I am calling them as employees, all employees, right? So this is how the difference between entity type and entity set. Okay, let's move on to the next question. So explain different types of relationship among the tables in a database. So which is an very important and like I won't say it's a frequently asked interview question, but it's good to have this knowledge, while because if you are asked to develop any OOD like object oriented design or LLD or low level design, so this is very important. You must have to point these things. Okay, you must have to tell the relationship between two different tables. Okay, in that case it is very important. Okay, so here we will be having 3 types of relationship. One is like 4 types basically. Yeah, so first one is one-to-one relationship. So what is this one-to-one relationship? So just imagine you have one table here and you have one table here, and in this particular table one row has some relationship between one row in the table 2. In that case we can say that it's an one-to-one relationship. Okay, and this one-to-many relationship means, let's say you have a table 1, okay, where one row from the table 1 refers to the multiple rows in the table 2. Now what happens? So this is called as an one-to-many relationship. Like you can watch out these examples, right? So that's why I'm not telling them. And the next one is many-to-many relationship. So many-to-many relationship means, so from table 1 many rows, okay, many rows refers to the many rows in the table 2. Okay, then that is called as a many to many relationship. So the next one is self-referencing relationship. So self-referencing relationship means if your rows, okay, in one table refers to the another rows within the same table, then that is called as an self-referencing relationship. Okay, and there is another thing as well, many to one. Okay, like many to one relationship means many columns, like many rows from the table 1 referring to the single row in the table 2, then that is called as a many to one relationship. I hope you got it. So now let's move on to the next question. So explain that difference between intention and extension in a database. Okay, so intention and extension. So basically intention refers to the database schema. So yeah, intention are popularly known as a database schema. So if you don't know what is database schema, I will tell you. Okay, I will tell you what is database schema. Database schema. So if you consider a database where you will be storing all your student details, then whenever you you decided to create the database of students, you should be figure out what are all the attributes that you need to store, right? So it is a student ID, name, branch, email ID. So you will be creating this skeleton. Okay, so you are telling that for every student we will be having all of them, and whenever you are trying to insert data into the database, you must need to provide all these data. Okay, so that is this particular skeleton is called as a database schema. So a database schema is used to define the description of a database and is specified during the design of database, right? So when can you when you will you decide all these attributes? So whenever you have planned to create a database for student, right? So in the beginning of the storage as well, okay, while you decided to design, then you need to decide to store, then you need to design an ER diagram, and then you need to mention all of them in that particular diagram itself. Okay, that is called intention. And if you design it once, if you define the schema once, it cannot be modified later. Okay, I will tell you the reasons why we cannot modify that later, the later part. Now the extension. So extension on other hand is the measure of number of tuples present in the database at a given point of the time. So okay, we are done with schema. Now we started inserting our data. Okay, inserting our data. Okay, I have all the schema ready. Schema ready. Now I will start storing the data into the table, right? Now at some point, okay, after inserting some 10 rows, 10 student records, I wanted to figure out how many students tables that I have inserted so far. Okay, then I can figure out that I have inserted 10. Okay, which means it is called as an extension. Okay, so the extension of database is also referred as a snapshot of database, and its value keeps changing as when the tuples are created, updated, destroyed in a database. Like it's just an information or description about your database so far, like what are all the things happened and what are all how many data are present. That's it. Okay, let's discuss another question in the DBMS interview preparation. So explain the difference between a delete and truncate commands in a DBMS. So as we discussed during the languages in DBMS, we have talked about this delete and truncate, right? So now they are asking about the differences between the delete and truncate. So if you remember, I have told both are being used for deleting the data only, but it differs in something else. Okay, we'll talk about that in detail now. So a delete versus a truncate, so which is a very important question. Okay, very important question in interviews perspective. So basically this delete, okay, this delete will delete the rows, okay, delete the rows, but with some condition, okay, with condition, which means let's say I have all the data of students. Okay, now I wanted to delete the student data whose roll number is equal to 200. Now here I have a condition, whoever a student whoever having a roll number of 200, I need to delete that particular record itself. Okay, I need not to delete entire data, okay, like all the student details. Now I have to delete only this 200 roll number student only. So here I have some condition, I will be deleting that particular row. Now after deleting that particular row, can I get that back? Yes, you can roll back. So if you remember, we have discussed about commit and rollback. So commit will help you to save the, like, preserve the changes, and rollback will help you to get your like deleted or eliminated things back. Okay, yes, you can roll back. Now coming to this truncate, so again it will delete the rows. Okay, it will delete the rows, but here with no condition, with no condition. It means that if you truncate one table, like it will truncate all the data, it means delete all the data present in a table. Okay, it won't even keep single row, single record of a student. It will delete all the data from the table. That's it, without any condition. Now my question, like you might be wondering, can I get the data back? Yes, you can. Okay, you can roll back it, but it has some limitations in it, like few versions of MySQL databases doesn't support truncate rollback. Okay, only few things will support the truncate rollback. So if you do that, you might face the data loss as well. Data loss means like suppose if there are 1,000 records, then if you are trying to roll back, you might get 800, or your data might get corrupted as well. Okay, and which one is faster and which one is slow? So this one is slow little bit and this is fast. Why? Here you will be having some conditions, you need to check, right? You need to traverse through all the data, you need to search for that particular condition, then only you need to delete. On top of that, you will be maintaining your logs as well. Logs means like what are you doing, what are the data you are deleting and all, because you need to roll back, right? So but here you don't need any conditions, you don't have any conditions, all you can do is just delete everything. Okay, so it is faster, and also it won't maintain logs as well. Okay, it won't maintain logs as well, means like as we discussed. So that is the reason why while trying to roll back, you might face a data loss issues. That is the difference between delete and truncate, which is very important question in an interview. Let's move on to the next question. So the next question is, what is a lock? Explain the major difference between a shared lock and exclusively lock during a transaction in a database. So which is very easy question, like in terms of all the transaction questions I hate. Okay, so it says that like shared lock. First we'll talk about shared lock. Okay, so what is a lock first? So basically you will be performing like, so let's say you have a DB, and this DB has access to many servers, right? Many servers, so many people can access this data. Now let's say I am performing some write operations here, like I'm trying to, let's say I have account balance as 100 rupees. Now I'm trying to delete, okay, I'm trying to withdraw 50 rupees. Okay, now at the same time, like let's say person, or let's say father, son and father, okay, son and here father. So they have joint account, okay, and son is staying in hostel, so he wants to withdraw all the money, and father is staying in some other city, he also would like to withdraw only. Now son assumes that he has seen fetched that particular current balance, and he has seen there is 100 rupees. Now he decided to withdraw 50 rupees, and at the same time dad also trying to withdraw the amount of 100 rupees. Now what happens? It will either fail, usually it will fail, but to handle such kind of situations we will be having these logs. Okay, so if one user entered into state, then we are locking him and we are not allowing other users to access the data. Okay, so this is how a lock mechanism works, and we'll now have two types: shared lock and exclusive lock. Okay, we'll talk about the shared lock now. So shared lock means for read operations. Okay, so let's say we have a account, joint account, where I have 10k in my account. Now my dad is also trying to check the current balance, and me also trying to check the current balance. Now will there be any problem? No, right? There is no problem. It's just a simple read operation. We are not withdrawing the amount, means not writing the amount. Okay, so it's just a read operation. So you can allow as many users you want. Okay, in shared lock has been used for a read operation specifically. Okay, and you can allow as many users you want to access the same account or same database at the same time. Okay, this is about shared lock, and the next one is exclusive lock. Exclusive lock. So in shared lock we are using that for read operation, but in exclusive lock it will use for write operation. So as we discussed the problem earlier, so write has to be only one person can perform a write operation. Means let's say if son is trying to withdraw the money, so it should not allow the father to withdraw at the same time, because it will lead to the inconsistent state. Okay, they might face a problem in the future. Now what I can do, so let's say I have a account or ATM now. So whenever someone has either whoever comes first, so try to withdraw the amount. Okay, withdraw the amount, then you need to lock that up. Okay, so someone is trying to withdraw, then you need to lock this particular account. Okay, until this person completed his transaction. So after completing the transaction, you should remove this lock and allow other persons to access the same account. Okay, then they won't see any problem, right? So because they are going one after one, they are not doing the operations at the same time. So after completing one particular task, data will get updated and father can see that there is no balance. Okay, there is only 50 rupees. Okay, I can't withdraw 100 rupees. Okay, so this is how we can use this locking mechanism to avoid transaction failures and data inconsistency. Now the next question is, what is mean by normalization and denormalization? Okay, so a normalization is very important. Okay, very important topic for interviews. So we will be talking about different types of normal forms available and how to write them and how to create them as well. Okay, now just keep this in mind, normalization is very important topic. So a normalization is a process of reducing the redundancy by organizing the data into multiple tables. So just imagine, okay, just imagine you have a very big table, okay, very big table where you will be storing all your data in single table. Okay, it's a single table. Okay, like where you will be storing all the let's say if you are Amazon thing. Okay, so this table is storing all your Amazon data, like customer details, order details, and payment details, all you are storing in this particular single table only. So now what happens? What is the problem? So it keeps on increasing in an exponential manner. So at some point of the state, it will be overburden for that particular table as well to maintain such a huge database. At the same time, you might be taking different uh, different duplicates in it. Let's say, so I will be storing customer details at some time, let's say 100, and the same time this particular student customer ID has performed some payment failure, so you will be storing that. So payment success, you will be storing that. So he has ordered something, you will be storing that. So it keeps on storing, expanding, right? So you will be having different duplicate data. So to avoid these kind of problems, we have come up with a solution called normalization. Okay, so what is a normalization? So a normalization divide your big one table to the different small tables, so that the chances of like having a duplicate data will be less, and you will be like you are accessing the data as well from the database will be little faster when compared to the single database. Okay, single table. Okay, that is what, and it is also easy to maintain as well, right? So you like if like you are avoiding single point of contact as well. So if that table has been stuck, everything, your entire application has been closed. Okay, you can't use that. So to avoid such kind of problems, so try to normalize your data and try to divide, not to store your data in single table. Okay, try to put it in a different tables. Okay, small tables. Now what is a denormalization? So it's an just and reverse process of to the normalization. In normalization, we will be saving the things from one big table to the different small tables. But in normalization, we are doing it in a reverse manner. Means we are keeping all the we are combining all the small table data into a big single table. Okay, that is called an denormalization means. So yeah, now let's talk about the different types of normalization forms in DBMS. Okay, so what is a normalization? So basically a normalization is a process of organizing the data in database, okay, to avoid a data redundancy and some anomalies. So what is a data redundancy? So data redundancy means simply you can call it as a duplicates. Okay, so what is anomalies? Anomalies are problems, okay, that were arised during the uh, data insertion in a table or well, like in database. Okay, so let's see. So let me write the definition of that following. Okay, a normalization is a process of organizing the data in a database to avoid data redundancy, anomalies. Okay, so this particular data redundancy means storing duplicates or means a duplicate values. Okay, anomalies means you can simply call them as a problems. So hope you still might be in a confusion. Let's see what does this. Okay, so let's take an example table. Okay, where you will be having employee ID, employee name, and employee address. Sorry, employee address. This is not address. This is let's consider this is a department, like where he belongs to. Okay, where he belongs to, and the department ID. Okay, department ID. Cool. So let's assume this is our database, and we do have some records in it. Okay, let's say when I say records, it might be, let's say, employee ID 101 and name is Vamsi. Okay, so employee department is let's say we do have department names like Godavari. Okay, so and department ID, let's say department ID is D101. Okay, D101, and we do have another record, let's say Reddy Krishna, he belongs to Krishna department, and department ID goes something like this. Okay, now we do have another thing. So Vamsi, sorry, Vamsi, and he belongs to Spider-Man's team or Avengers, whatever you may call. Okay, and also a Vamsi is like 101. This person is again belongs to another team. Let's say Krishna. Okay, he belongs to Krishna team also. Now let's see. Now let's see what are all the anomalies we might get. Okay, so first one, tell me. So let's assume here Vamsi is like 101, 101. Okay, now there is two records associated with 101 employee ID. Now I wanted to update the address of a Vamsi. Okay, I wanted to update the address of an 101 employee. Now how many times I need to update? At 2 times. Now let's suppose I forgot. Okay, I forgot to update for 2 times. I have updated only for 1 time. Okay, I have updated this guy. Okay, so I have made it as a Bangalore, and still he belongs to a Mumbai. Now tell me, is this a problem? This might be a problem, right? So this kind of problems is called as an update anomalies. Okay, update anomalies. Now let's discuss about a delete anomaly. A delete. Now let's say, suppose I am trying to delete the department. Okay, so like we have an Spider-Man department with the department 103 ID. We are trying to remove that entire department, like means decompose that particular department. Okay, now so if I delete this particular department, this entire record will get deleted. There might be a chances. So what is happening? We are losing one person. Do you think that? Yes. So that is called a delete anomaly. Okay, now what is an insert anomaly? So let's say so this particular department ID is a primary key. Okay, this is a primary key. Now I'm a new joining. Okay, so I joined in a company 2 days back. So still I am in an training phase only. No department is being allocated for me. Okay, now some people is trying to update my database to get an ID card for me. Okay, so now tell me, do I have a department ID currently? And no, because I am not assigned to any department, right? So whatever the data I have is this particular employee ID, let's say 104, and a name, let's say Sai. Okay, so I don't have department, employee department and the department ID as well. So it won't take the this record, right? You record these code. Sorry, you record it won't take this particular record. So what happens? Okay, so it won't take that record. So we lost the one particular employee name. So that kind of problem is called as an insert anomaly. Okay, insert anomaly means that during the insertions, like insertion into the a DB. So delete anomalies means while deleting the data from a DB. Update means while updating the data which is present in database. Okay. Now this is about normalization and anomalies. So how we are going to solve this kind of problems is called as an normalization. Okay, so we do have different types of normalizations. So those were or classifications. Okay, you might call it as a classifications as well. So first one, 1NF, 2NF. So first normal form, first normal form, a second normal form, 3NF, and BCNF. And we do have a 4NF and 5NF, but this were not necessary. Okay, not necessary. What does it mean not necessary? So whenever we achieve this BCNF for a particular table in database, then we can say that there will be no data redundancy, there will be no anomalies. Okay, so we can say that that particular table is all set. Okay, so we don't require these things. Okay, so that is the reason why in interviews also, in most of the interviews, they don't drag this 4NF and 5NF topics. Okay, they will end up at BCNF. Okay, not even BCNF. Yeah, so in some cases they will ask you BCNF, otherwise they will just ask you to define this what is 1NF, 2NF and 3NF. But when I say like when they ask you to define, it's your responsibility to take an one example and then you need to explain it, because in an interviews mostly interviewers are not interested in hearing the standard textbook definitions. They want something like more than definition, like let's say concept. Okay, what you have understood from that particular point. Okay, that is what they want. Okay, that is what they are expecting from you as well. Okay, now let's see what is 1NF. Okay, let's start with 1NF. Okay, let's say we have a table like this. uh, Student ID, student name, and student mobile number. Okay, student mobile number. So what is the data? It has a student ID is 101, 102, 103. Names are Vamsi, Reddy, Sai. Okay, so now mobile numbers are, this guy has a two mobile number. Okay, so I am writing only 5 digits. Okay, so consider in real case. Okay, so another thing, another mobile number is this, and this guy has this, and this guy has this. Okay, these are all the mobile numbers they are holding. Now tell me, so the formula of like what is the principality of 1NF is an attribute of a table cannot hold a multiple values. Okay, it should hold only atomic values. Atomic values in the sense it has to contain only one value under one particular attribute. Let's say, so in our case, under student mobile, we are holding two values, right? So this is not the 1NF principle. So we need to convert this table into the 1NF, right? So we need to convert this table to the 1NF. So here what we can do now, we can simply flat this like entire table. So when I say flat, let's say what we can do now. Okay, so what we can do, let's say 101 Vamsi 1, this one is 1, and I can make this 13425 with another new record. Okay, so same ID is same, student name is Vamsi, but mobile number is 13425. So now there is no problems in this 102 and 103. If suppose again 102 has uh, 2 or 3 mobile numbers, let's say 3 mobile numbers. Okay, 3 mobile numbers. Okay, so now again this, with this particular student ID, we do have a, we might have a 3 records, okay, in our flattened, in our 1NF converted table. Okay, so something like this. So here we will have first number, here we do have a second number, here we do have a third mobile number. Okay, so this is what first NF, first normal form. Okay, now let's talk about a second normal form. So let's first discuss the principles of second normal form. So here the principles are, first thing, a table must be in 1NF. Okay, so whatever, so whenever we are trying to convert one particular table into an 2NF, that table must be in a 1NF. Okay, it must has to satisfy that principality of 1NF. Then second thing is no non-prime attributes. So non-prime attributes in the sense non-primary key attributes, okay, is dependent on the proper subset of candidate keys table, candidate keys. Okay, let's see with one example. Okay, I'm sure by seeing these definitions you are not going to learn anything apart from mugging up those definitions. Let's see. Okay, now let's see. So we do have a table something like this. Okay, so a student ID, a student name, and a student age. Okay, so student ID is a 11, so let's say 11 triple one. It's not a student name, let's consider it's an course, okay, which a student has been enrolled. Okay, so 101 student ID is enrolled in, let's say, DBMS subject, and his age is 21. Now again 101 student might be enrolled in other courses as well. So what is that course? It's a OS, like operating system. So again his age is 21. So we do have another with a student without ID 120. Okay, so he is also enrolled in computer networks. His age is 22. Okay, now another guy with 120 sim, and he enrolled in an machine learning subject with age is 22. Okay, so this is the data we have in our table. Okay, now it's our job is to convert it into the 2NF. Okay, now let's say, can I say that this particular table is in 1NF? Yes. So for every attribute, it is containing only one value, so that I can say that it is in 1NF. Now we need to follow the second principle of this guy. Okay, so the here tell me what are all the candidate keys here. Candidate keys, only student ID, right? So the keys which are helpful us to identify the record uniquely, that is only this student ID. So what we can say, what we can do, so here our primary key is, prime key is student ID. Okay, primary key is a student ID. Now what they are saying, so they are trying us to, every non-prime key attribute has to be dependent on primary key. That is what they are trying to say. Okay, let's say, so what we are trying, so can I say that this course is depend upon this particular student ID? So if I give you particular student ID, can I say all the courses that that he enrolled in particular semester? Yes, I can say that. Now tell me, if I give you particular student ID, can I say that so can I get the age of that particular student? Yes, that might be the case. So it's your table has been simplified something like this. Okay, so let me draw here only. Okay, so what I am trying to do now, so first I will have two different tables. One is a student age, age table. So where I will be having details of all the ages of a particular student ID. Okay, let's say here this guy, triple one, student ID with triple one having an age of 21. Okay, now again to triple one 21. Yes, we do have that. Now again 120 22 age. So 120 and 22 age. Now again 120 22 age. Now whenever I want age of particular student, okay, now I can simply give you the student ID. You will give me the you can give me the student age. That's okay, fine. Now what about this course table? So I will leave you that course as it is, because so if we wanted to make it as a, how can we make it? So you can make it like this, but we are violating the principality of 1NF. Hope you have remembered the definition of 2NF, right? So that table must be in a 1NF, and also that has to be in an like all the 9 non-prime key attributes must be associated with the prime key attribute. So I will leave that course table, I will leave that course table as it is. Okay, something. So let's say 111, 111, 120, 120. First guy is enrolled in DBMS, then OS, then CN, then ML. Okay, so whenever I want this particular student age, I will simply make a call to this guy. Okay, done. This is what 2NF. Okay, so it's very important to know the examples. Okay, at least if you are in an interview, you have to say these kind of things. Okay, so not even like simply drawing all the stuff. Even let's assume you can say something like this. Let's assume, sir, we have one table with the attributes like student ID, student name, and the student age. So here the principles of second 2NF is the table has to must be in 1NF, and it all the prime non-prime key attributes must be dependent on the primary key. Then you can divide those things into a multiple tables. That's it. Okay, now we'll talk about 3NF. 3NF. So what is this 3NF means? Let's say, so I can say that it has to be in table must be in 2NF. Okay, table must be in 2NF. That is for sure. Now apart from that, so there will like let's say transitive functional dependency of a non-prime attribute on any super key should be removed. Okay, so yep, it doesn't make sense to you. I will take one example and we'll see what it is actually. Okay, let's say we have a table of employee this time. Let's change the table this time. Okay, let's say employee. So employee ID, employee name, and employee address. Now let's consider address. Okay, so pin code. Okay, so pin code or zip code, whatever you might call. Okay, and then I am storing the state, then employee city, then employee district. Okay, so it has some data. Let's assume we have all the data. Now what I'm trying to say now, so this, if I give employee ID, I can get this entire row uniquely. Is there any key something like that? No. So here candidate key and primary key is employee ID. Now, is there any possibility of decomposing this table again? So think. Yes, I can say one thing. So now let's forget this entire table. Now let's assume we have this only table. You have this table. Now can I say that this, if I give this entire pin code or zip code, whatever it might be, so can I get the entire row in this particular table? Yes, right. enter pin code and zip code, or pin code or zip code is very unique. Okay, it must not be given to another state, like another districts or another places or another legislatives, right? So what I'm trying to say, so I will decompose that entire table into two tables. So I will have employee ID, employee name, and employee pin code. Okay, I will have something like this. Now I will make this pin code connected to another table called address table. Address table, where I will be storing all the pin codes. Okay, let's say I will have a pin code, then a state, then a city, then district. Okay. Now, whenever, so I will give all the pin codes here, particular employee. Now, whenever I search with this pin code, I will get a entire state and city and district details. That works. That works, right? So this is about the 3NF. Now, now we'll talk about the BCNF. Okay. Now we'll talk about the BCNF. So the full form for BCNF was voice a code a normal form. Okay, voice code normal form. So again, the conditions like our principles of this particular will be, so it has to be in a 3NF for sure. The table must be in 3NF. And a second thing, so like I can say that BCNF is a little strict than a 3NF. Okay, so a table complies with BCNF if it is in, if it is an in, sorry, if it is in 3NF and for every functional dependency. Okay, let's say x to y, x should be super key of a table. What does it mean? Let's say suppose, let's take one example. There is a company where employees works in multiple departments. Okay, employees works in multiple departments. Let's see. So employee ID, employee nationality, employee department, and department ID, department ID, and a number of people in department, particular department. Okay, now we'll see. So employee ID is 101, and employee nationality is Indian here. Department, he works for Godavari. Department ID, let's say 101, and in particular Godavari there were 250 people were working, let's suppose. Okay, and you do have so again this 101 guy, so 1001 guy also works in another department. Let's say again he is an Indian, so he's another department is Krishna, department ID is 102, and in that particular department let's say 100 people are there, and there is a guy with 100. Again, he works for two different departments, and his nationality is American. Again, he works in both Godavari, Krishna, 101, 102, 250, 100. So this is the table that we have. Okay, now let's try to identify. Okay, so let's try to identify. So can I say that can I say this entire employee functionality is dependent on this, employee nationality is dependent on this employee ID? One thing, yes. Now I can say that employee ID gives you employee nationality. Now what is the other case? So can I say that employee like these things, Department ID and number of members in a particular department is dependent upon this particular department. Yes, employee department. Yes, so I can say that employee department is equal to employee department ID and number of employees. Okay. Now, how we are going to take this into the BCNF? Okay. So we can break this entire table into 3 tables. Okay, let's say how. So first table, let's say nationality table. Nationality a table. So in that I do store employee ID and employee nationality. Okay. So 001 is an Indian and this guy 1002 is an American. That's it for this particular table. Now I will have another table. Okay, so where department table. Okay, department table, let's say we'll have department ID, department people, like number of employees. Okay, so first department we do have Godavari and ID is 1001 and number of people this. And then we do have a Krishna and it is a 102 and we do have 100 employees in that. Okay, that's it. Now we'll have another table which is currently mapping to that particular both tables, right? Let's say so now I will, in this particular table I will have only the primary things. Okay, primary attributes. Let's say what is the primary attribute in a table 1? It's an employee ID. Now what is the primary attribute in a second table? It's an employee department. So now I can say that 101 belongs to Godavari. Again 101 also belongs to Krishna and 102 belongs to Godavari and this guy belongs to Krishna. Done. So whenever I need entire department details, I will go to Krishna. I will get that. Whenever I need an nationality of a particular employee, I will go to nationality table and I will get the nationality. Okay. So that's all about normalization. Okay, so I highly recommend you to think on your own. Okay, like try to frame. Okay, take a couple of examples and try to divide those things, what kind of problems that you are going to get